Director at the Indo-German Energy Forum Support Office, which is a bilateral program between India and Germany. Let me start with a very warm welcome to all our delegates and participants. A special welcome to our distinguished speakers. I can see two of our speakers slated for today who are already here. Welcome Mishra Saab, who is the chief guest of today's program. Welcome Mr. Hans Judek Henning, who is joining us from Japan. I'm not too sure if other speakers have also joined us today. A hearty welcome to our foreign guests and other delegates who are joining from different parts of the world. Let me give a brief background about what is IGEF and what we have been doing in a couple of minutes. As I mentioned, Indo-German Energy Forum is a bilateral program which was started way back in 2006 in Hanover Fair in Germany, and it was inaugurated by the then Prime Minister of India and Chancellor of Germany. It is a high-level political dialogue platform which looks at experience sharing, best practices, and lessons learned or lessons to be transferred from both India and Germany. We have been working on innovative technologies in solar, wind, and grid integration. As part of these activities, what we did a couple of years ago, rather precisely 3.5 years ago, we started best practice study tour within the country. Earlier, we used to have study tours to Germany. We initiated along with our co-organizers, the Central Board of Irrigation and Power, study tour to important sites within the country. So far, we have organized 5 study tours, physical study tours, I mean, precise. This is comprising study tour to Kadamparai PSP hydro power plant, the solar power plant in Tamil Nadu, and then wind power plant, again, Suzlon wind power plant in Tamil Nadu. Then we had the physical study tour or best practice study tour, the floating solar power plant in Wayanad, which you will get to see the best practice study tour as a virtual study tour tomorrow when the KSEB officials make a presentation. The objective here is to give you a feel of how a plant operates, I mean, through description during the virtual study tour. As part of the study tours, we have always organized a seminar so that there is exchange of information, exchange of experience, both with the experts and also among the delegates. That has been the kind of activity that we have been doing. In fact, we wanted to carry forward those physical study tours because of the COVID pandemic. Unfortunately, we have not been able to continue with that activity. So both CBIP and IGEF came together and said, why not we initiate the virtual study tours? Exactly 3 months ago, we had the first virtual study tour on the pump storage. It was a virtual study visit to the Kadamparai 440 megawatt study, I mean, PSP plant. That again had the presentations by very eminent experts, exchange of information. We had about 100 delegates also from neighboring countries and all that. And as I mentioned, these 5 study tours that we have organized so far has evoked excellent response. We have had about 300 delegates visit as part of the best practice study tour. Coming to today's agenda, we have 4 presentations lined up today, other than the address by the chief guest, Mr. S.K. Mishra, Director of SECI, which is very active in the floating solar domain. And then what I would like to talk about the profile of the registered delegates. Since we will not have an occasion to introduce yourselves, let me tell you about 105 delegates have registered for this program. And we will definitely share the mailing list, and so that you can be in touch with some of the experts and some of the interested partners. The whole objective is to create a network, and therefore Our CBIP colleagues have also created a WhatsApp group, and if anybody has an objection, you can opt out of that WhatsApp group. It's basically for exchange of information and also for exchange of any queries or doubts you have after this whole seminar is over. Coming back to the profile of participants, we have the state nodal agencies, we have the private sector, we have the government agencies. Very interestingly, we also have about 25 participants from the Nuclear Power Corporation of India. I know that Nuclear Power Corporation of India must be trying to venture into a lot of renewable activities. I also remember they were there in the last study tour, just for the interest of the other developers and other interested parties in this training program. There are enormous opportunities for each one of us to really look at in the floating solar domain. We have people from Tata Power, we have people from MEDA, NHDC, NHPC, Brittle, KCB, and the list goes on and on. We have delegates representing close to about 40 organizations from both India and abroad. With these few words of welcome and introduction, a couple of sentences on the housekeeping measures. Keep your both audio and video, if possible, video also muted. I mean, you can keep your video muted, but certainly audio muted, because we would not want any kind of disturbance while the presentations are on from the experts. In case you have any questions, kindly either raise your hand in the chat, or you could post a query in the chat box, so that these queries or concerns or questions could be taken up at the end of the presentation. Each presenter would take roughly about 30 to 40 minutes, and then these are followed by maybe 10 minutes of question answer. With this housekeeping measure announcements, now I would request Mr. Bhatnagar, Director at CBIP, to make a formal welcome on behalf of CBIP. Mr. Bhatnagar.
And good afternoon, all my friends, participants, and the faculties. All experienced team is there, and I welcome you all. This is a joint program of CBIP with IGEF, and it is a very the program which is required on today's line. So this is an online training program on floating solar PV project and data communication infrastructure. So there will be a good takeaway for all the participants, I am very much sure. And in this period of COVID-19, which has affected the offline classes, this is a very good platform of learning on web, on online, because physical conferencing or activities are for some time it is on hold. So floating solar plant is an innovative approach of using photovoltaic modules on water infrastructure to convert the land along the increase in the efficiency of module. Additionally, the water is also conserved due to reduction in evaporation of water from water body. The modules in floating system operates under such cooler environment, and this additionally the dust collection issues are to be minimized, leading to enhanced generation and reduced cleaning frequency. Beside enhancement in generation, there is no cost of acquiring additional water for module cleaning. So I know we have one of the best faculties with us, and I welcome in this program Mr. Mishra, who is a well-known figure in the solar industry, who's Director Operations, and he is one person who is very aggressive, energetic, and go-getter, and we learn from him a lot of things. Mr. Mishra, you are welcome on this program, and you with your knowledge, everybody will be getting a lot of takeaway. I also welcome our senior faculties, Mr. Hans Henning Jodet, Mr. Andries Fransko, and Mr. Jamonaga. And sir, with your participation in this program and with the background knowledge of Mr. Mishra ji, there will be a great takeaway for all of us. And I will not be taking away any more time and hand over this program dies to Mr. Mishra to continue. Thank you very much and welcome all on this program. Thank you very much.
Thanks, Bhatnagar sir.
Welcome, sir.
Sri Anil Kumar ji and all senior faculties and the participants who are attending the program, senior officers of the different organizations. The topic chosen by CBIP is very relevant on the today's perspective, the floating solar power plants. The issue is that this when the solar and the renewable sector has grown in a very big way in India, it has already reached to around 80 gigawatt. Then the problem of the land and the other issues has started coming. Now you must be hearing the different issues of the land in different states, whether it's Tamil Nadu or whether it is Gujarat. A lot of issues of the lands are coming, and getting the lands has become a tedious job now. Although land is available in India, but converting it for the project is a tedious process. Then when the floating solar concept has came it is started in the world in slowly. Solar Energy Corporation has floated a expression of interest in the year 2018 initial time, and we have received a very good response from all the bidders for the participation in such type of plants. So based on that, Solar Energy Corporation has come out with one tender at the Rihand Lake of UP after agreement of the UP government to purchase the power. That tender was got the very good response, and the rate arrived at the time was comparatively very good in comparison to what the rate was coming for the ground-based solar plants at the time. 3 rupees 21 paisa as the per unit cost has come. That was the beginning of the process in India in the big plants. And if you see around the world, the plants are not of very high capacity has been installed. So far, approximately 2 gigawatt has been installed, and that majority of that in last 2 years. And approximately 50% of the plants are more than 15 megawatt. Earlier, it was in kilowatt level. In India, also kilowatt level plants are installed at various places, whether it is Calcutta or different places. Now when this success of the Rihand plant has come, then a lot of tenders has started coming in India for the floating solar. Kerala has recently issued for 50 megawatt. Then NTPC is also regularly doing the floating solar plants, small capacity. Now the big capacity plants, now the future what is coming is approximately 200 megawatt will come in the Jharkhand, that is the Ketalsur Dam and Ranchi. That Solar Energy Corporation is going to do. Hirakund is also has been identified as a big potential in Odisha, and Odisha government has recently completed one study from the European Commission, and that the report is very exhaustive and very good report. And in that report, the total potential of the Hirakund and other places in the Odisha has been identified, and the very big potential in the Odisha for the floating solar. So what we find is in the recent some of the cases, the tender has been awarded for the Andaman. There also the rate has come along with the battery is very comparatively very good rate, very aggressive rate has been given in the Andaman Nicobar for 4 megawatt plant, and 15 megawatt plant is under tender for the Bhagara BVMB. Every organizations they want to capitalize what is the resources available with them. Bhagara is having the dams, they want to capitalize it. NTPC is having many reservoir in their plant, they want to capitalize it. So everyone has started doing this, and the state has also understood this is a very good way of exploiting the power. And if the hydropower is generator is there at the same place, so you need not to build any transmission system also, because these are complementary. In this rainy season, when the solar power will be less, then hydro generation will be more, and otherwise solar power is very good. So these are the advantages, and because of that, this solar floating has being promoted in India in a very big way. Government of India has already started monitoring and these issues, how to this increase the this uses of the floating solar, and they are regularly the meetings are taking place at the senior level. So how to capitalize this our different reservoirs. Advantage with floating solar, what you will get in different already lectures are there, lot many, but there are defined advantages there. Generations are comparatively more in comparison to because of cooling effect, and the water evaporation is also reduced a lot. I would like to tell you one of the issue when it has come in the UP, because initially when these plants come, the rates are comparatively higher than the ground-based plants. So one of the issue has been raised by the regulatory commission. Why should I purchase the higher cost plant, higher cost of the power when I am getting the cheaper solar power, and I am getting is 2 rupees 75 paisa at the time, 2 rupees 80 paisa. Now it has come to around 2 to 30 around that. So then we have given a great, we have given an explanation and all the calculations to them. Then water evaporation loss, what is happening and which is not being counted, that we have calculated. And then given to that what the water you are going to save on this, and what the land you are going to save. These two factors are giving more advantage than what is the ground-based system is giving. So then commission has satisfied with our reply and adopted that tariff. So this is how the journey has started in India for that. And the recent rates, what is coming in the floating solar is very good rates. Only thing is that the floating, if you properly analyze the floating plants, you do the proper bathymetric survey and the soil condition and geotechnical analysis, if readily available, then bidder can quote in a better way and better rates can come to the bids. So this we understood from some of the tenders, and now we are doing in the similar direction. Lot many multilateral agencies are helping us. France is helping in that. For they have already analyzed the capacity in Uttarakhand and Jharkhand for the Solar Energy Corporation, and World Bank is doing for us. It's for the Odisha. So these all multinational agencies, they all are helping for establishing of these floating solar plants. In some of the case, we are getting the offer like that. What is the difference between the floating solar cost and the land cost? That cost can be compensated from the multilateral agencies. So this type of issue has started coming, and everybody wants this to be promoted. Lot of issue again raised by the environmentalists. This if they cover the more area, then what will happen? Then they will what will happen to the fish and what will happen to the other issues. That has also been different studies were carried out by the series in Singapore, and the reports are quite encouraging, and there is not much of the issue. Recently, we have also conducted a study for the floating solar plants in the lagoon area of Lakshadweep. That report has recently submitted to us, and the report is also concluded like that. It is not very discouraging to install the solar plants. It is a good sign, and not much of the effect is coming. What the temperature is getting reduced or oxygen is getting reduced because of this coverage, that has also been analyzed in detail. And ultimately, the clearance has been given by the environmental agency. This can be put up for the final approval. So we are planning to install the floating solar of the good capacity in the lagoon area of the Lakshadweep also. That is also a plan. This way, I would like to tell that this session is well timed, and already so floating solar business has started in a big way in India, and with the learning from the session, I hope this will help in the further understanding the issue across the country, so that people will understand why this type of plants are very good, because the potential of such type of plants, if you see the various studies, are very high. World Bank report says is around 400 gigawatt. But what I found, if you see the total surface area available, water bodies, water body available in the different continent, if the 1% only you utilize, so that comes to 504 gigawatt. If you utilize 10%, then it will go to 5,000 gigawatt. So this is the capacity we can install even by utilizing the 10%. There are lot many other challenges are there that has to be discounted. So these are the it is very good future for the floating solar, and as this session has started with the RE Invest program is also going in the parallelly in the different forum. There are also a lot of issues, are such type of issues are discussed, and you see the renewable part, the renewable has a very big potential of replacement of the conventional power. We have the very strong view. This RPO requirement issue has over now. That is not required at all, because the cost of the renewable is reduced so low. It is economic sense to purchase the renewable in place of, rather we have to start replacing the conventional power slowly with the renewable to reduce the power purchase cost. If you see the recent report of the Rethink X, that is a think tank in the US, and Mr. Tony Seba is a head for that. So the report what says, they have very great detailed study for the US 3 cities, and they said this by 2030, starting from 2020 to 30, all conventional power in the US can be replaced with the round the clock renewable powers along with the battery, and the cost of the power will be half of that what is today's. So these are the things people are talking, and what they are telling earlier also, that is getting true. So we have also requested Mr. Tony Seba, we have given the data of India to him, so that he can present a small introductory for the in the perspective of India. Tomorrow 9 o'clock to 9:30 is the scheduled in the RE Invest. That is a very great name in Tony Seba. I request all of you to please log in at that time and hear what he's telling. Such type of orators are very, and what I see the history of him, so whatever predictions he has done so far around the renewal, it is coming more or less true in the costing point of view. So this is a short, and I request all of you to please go through the during the session, you take the different issue, whatever is being discussed, and have the question answer properly, so that India will be having the great future of the floating solar with the persons like you who are attending, and we can have the understanding of the what are the intricacy on these plants, because water gets down, then what will happen, and this is lot many challenges are also there, that all aspects has to be understood, so that India can develop this type of infrastructure in a big way. Thank you very much. Thank you CBIP for calling me, and I am very thankful to you.
Thank you, Mishra Saab. I mean, on behalf of IGEF and CBIP, we are indeed very grateful for setting the tone for today's training program, and also giving an overall perspective of what's happening in the country. You referred to the various tenders that SECI has floated on, specifically on the floating solar, and also the regulatory issues. I mean, it was really nice that you brought up that issue, how the values of water and land saving have been taken into account, and you did a very convincing response to the Regulatory Commission. I think people from different agencies who are participating will be very pleased to know that. I thought I will give the floor to some of the participants in case they have a couple of questions to Mishra Saab before we start the regular session. I mean, in case you have any question, kindly raise your hand so that you can put your question to Mishra Saab, and then you can get an answer. Just 2 questions if there are any. Anybody would like to ask Mishra ji of SECI? I mean, any question? Yeah, I see somebody raising a hand. You can unmute yourself and ask a question. Yeah.
What is the procedure of cleaning of this plant, that is panel? Will be tedious job, I think, in case of in floating solar.
Basically, when we design the plant, then walkover arrangement is being provided in that, and there is not much of the issue, because already there are a lot of plants in the world has commissioned at the big level of 40 megawatt, 50 megawatt, and the dust pollution is comparatively less in that area. So this all has been taken care of. Otherwise, you cannot run the plant.
Thank you, Mishra Saab. One more question in case there is one.
Sir, am I audible, sir?
Yes, you can. Yeah, introduce yourself and then you can pose the question. Yes.
GM from Jharkhand. So, sir, my question is, can we have detailed report on impact on aquaculture?
Yes, yes. When we for the Gatasul Dam, when we carried out this study, so this part has been covered, and we have already forwarded to your water department, and we can give to otherwise also, if you send a mail to us, we'll send you. And when we carried out the similar type of things in the Lakshadweep, there also the report has been detailed analysis. What will be the impact on the aquaculture? It all has been covered in the report.
Thank you, sir. You can send in your questions later on, and then we will get a response from Mishra Saab even after this program is over. Thank you, Mishra Saab, for giving a different, an overall perspective of what the whole country or the globe is looking at from the floating solar. Thank you very much. Thank you so much. Thank you. Now we will get on to the first session or the first presentation. This is by Hans Henning Judek. Before he commences his presentation, let me give a brief profile of Mr. Hans Henning Judek. He is the Executive Chairman of Energy Visions Japan and CEO of the JE Access Limited. It was initially established to represent various innovative technologies to the complex Japanese market. He is also the CEO of Next Generation Solar Technologies Private Limited in Singapore and Executive Director of Next Generation Solar and Storage Energy Private Limited, Madurai in India. He has about 40 years of experience in technology transfer topics. He has a nose for new technologies and processes with high potential. He has also organized numerous technology transfers and trade relationships worldwide from his office in Yokohama in Japan. During the last 15 years, he has shifted his interest totally to environmental technology and has introduced new technologies and concepts in this field. He is now working on RE project development and especially on floating solar. In fact, I might call him as the grandfather of the floating solar topic. Bhishma Pitamaha of the subject. He also is the owner of the group of the floating solar on LinkedIn, which has about 1,300 members. I hope, Hans, people who are interested, they could join on your LinkedIn, right? That's fine with you, Hans?
Of course. Okay.
Okay.
I have actually one slide where people can see how it works. In the meantime, we are already at 1,370, so we are closing into 1,500, which is nice.
Great.
And they are all specialized in floating solar. So most of them.
Fantastic. So people who are interested in learning more about this, about technical exchange, experience exchange, so I think it will be a good idea to join him on the LinkedIn for the floating solar group. On his academics, he holds a bachelor's degree in economics and a master's degree in law from German Göttingen University, and also has done 2.5 years of postgraduate legal research at Kyoto University in Tokyo. The floor is all yours, Hans. We look forward to seeing your presentation. Thank you.
Thank you very much. So this is my second forum this month. It's a strange feeling sitting in front of your computer, knowing that there are many people looking at you, but you don't have a feedback. So what I did is I put a picture of a large crowd behind the monitor, so I at least get the feeling of talking to somebody. Anyway, maybe I give you a short brief how I got to floating solar. That was in 2013. I was developing several ground-mounted solar installations with a German friend of mine in Japan, and one day they proposed to me, oh yeah, there's a wonderful 6-hectare piece of property that is totally flat, no trees, no mountains, nothing. Okay, so I went there, and to my surprise, it was a pond. And the suggestion of the owner was, okay, no problem. You drain all the water, we don't need the water anymore. So drain the water, take out the 2 meters of sludge, and then fill it up with rocks and then some soil on top of it, and you have a wonderful piece of property for solar. Great idea. The little downside was that the price tag was about $3 million to just get the land into the shape that was necessary for solar. But I had, by coincidence, read an article about the real grandfathers of floating solar, Cieliter, you know them all. They had just installed one unit in Saitama Prefecture. And so I had heard about the floating solar. I started to did some research and got to a very interesting scenario. One downside was that the pond was owned by a cooperative, and they had in their statutes that they needed 100% agreement if there was a change of purpose of that property. And there were 2% very small shareholders who disagreed. So finally, by this little glitch, the whole thing fell over. But my interest was already there in solar. So let me just go to my presentation. I hope everybody can see that.
Yes, sir.
You can. Okay, very good, very good. Yeah, so development of the floating solar industry, recent innovations and common risks. That's also an important point. And I was already introduced as the owner of the
So could you fully screen it, sir? Sorry, sir. Could you fully
Sorry?
screen it? Yeah, fully screen it, sir.
I have
slideshow
full
mode?
screen here.
No, it's not showing fully screen. It's not in slideshow mode.
Oops, that's strange, because I have full screen here. That's bad. So what shall we do? I have the full screen here on my computer.
Now it's means it stops sharing, sir. You can share again, sir.
I said I have here a full screen on my computer. It's showing the full screen.
But here is means sharing of your presentation is stopped, sir. We are not able to see your presentation now.
Oh God. Huh.
You can just press skip and just try again to share this presentation.
Okay. So how can we do that? Just take out the share, hide options. Now I go in again and give it another try. Can you see now?
No,
yes, sir, presentation is there.
No, but it's not full screen. I think it's still okay, looks like. Yeah, it's not full screen, I can understand. Is CBIP IT team around? I mean, they want to...
So just just click on full screen, sir. Then it's.
I have full screen. I have full screen.
No, we understand. We understand you. I mean, Hans. I don't know. Yeah, it's. I am not too familiar with the IT tools. Is somebody there from the IT department of CBIP?
Yes, sir. Yes, sir. Yes, sir. I'm Ravinder.
Oh, okay. Okay, you are Mr. Ravinder. Okay, you are from. You have the presentation with you. Can you display that presentation?
Okay, sir. Okay.
If you can, is that okay, Hans, with you?
Of course, of course.
Okay,
of course.
Okay. So Ravinder from CBIP.
Then just say next slide.
Yeah,
Then
sure. You will
just
have,
next slide. Okay,
correct.
I just.
Yeah, Ravinder, go ahead and show the presentation from your side. Yeah.
Yes.
I hope I can see it now, because at the moment.
No, the presentation is still not on. No.
Right. Sorry for that.
No, that's fine. That's okay. Yeah, we understand the issue.
Fortunately, I send it over, so.
Yes, yes, yeah.
Okay. Oh yeah, there we go. Okay, good. And I can even see it, but I see only
the same size. I mean, yeah, it's not full screen.
I don't know what the reason for that is. It's a completely normal.
Let's see. I mean, he's trying to do that.
Just a minute, sir. Just a minute.
Sure. Okay. No, we'll take.
I'm sorry for that, really. We tried it out and it worked fine, so.
No, that's okay. Yeah. Sorry.
So I think that's it, what we have to deal with.
Ravinder, it's fine. I think it's okay.
Okay. Then put up the next slide, please. Next slide, please. Hello?
No, I think he has gone to the last slide. I don't know. Ravinder, can you
there
hear
we go.
us?
Okay.
Okay.
No,
Okay.
that's it.
Yeah.
That's it. That's the next slide.
All right.
So again, just briefly, we have this group, Floating Solar, and we have many specialists in there, and we have very interesting discussions, especially on upcoming technologies, also of problems that are occurring and so on. So it's worthwhile, if you're interested in this topic, to just join. And I would like to welcome you. Anyway, next slide, please. Next slide, please. Okay, yeah. So I started out in 2013, and I held a presentation at the Asian Clean Energy Forum of the Asian Development Bank in Manila with the title "The White Knight for the Mega Solar Industry." I could already foresee how this whole thing would develop, and we can see that now happening. So Korea is building 2.1 gigawatt, the largest floating solar project in the world. Thailand is planning 2.7 gigawatt. And can you click please once? Yeah, and the global solar capacity grows to 1.1 gigawatt. Click please. Yeah, there we go. So now in April, we had already 2.6 gigawatt. Floating solar PV is considered to become the third pillar of the global solar PV market, and that is already quite visible. 60 plus countries have actually already pursued. More than 35 countries are home to an estimated 350 operational FPV systems. Quite amazing. So by the end of the year, we will have close to 3 gigawatt of floating solar, despite of COVID-19. In the future, is FPV projected to experience an average growth of above 20% in the coming 5 years. It's quite amazing if you consider what we have already. Still, most people still consider it a niche market. Next slide, please. Next slide, please. Hello, next slide. Ah, yeah. So this shows the global distribution. You see a lot is in Asia, a lot. America is shown here very big, but it has very little installations. I'm working there at the moment, but it's still pretty small. Next slide, please. Next slide, please. Ah, yeah. So the current technologies is dominated by the idea that originally was proposed by Ciel-et-Terre. This is their design, to have one float for one panel and some walkway in the center. That was original. Can you, next slide, please. In the meantime, a lot of different similar looking contraptions are on the market. Some of them I fear will not survive the next storm because they are more a wind catcher than a solar catcher. We have seen that in the past, so it's pretty difficult to find the right balance between environmental risks and optimizing the solar yield. Next slide, please. Next slide, please. Yeah. So different configurations, but in principle, it's all the same. It is utilizing HDPE, plastic, filled with air that are supporting the solar panels. So this is a Chinese design that came up recently. Next slide, please. On the other hand, there are now also several new approaches. This is, for example, from the German company BayWar, Renewable Energy. They are using this roof type of setup, and they install the power plants in east-west direction. So they have a very, very strong record in low wind resistance, because it's the wind has no chance to get underneath. It's a very important point. I'll show you later. Please, next. So the latest considerations are quite interesting. It is using wood for the floats. The idea came up through some information about a company in Sweden that is producing 120-meter high towers for wind turbines. So the idea is to not using plastic anymore. The problem is at the moment for 1 megawatt, 45 to 70 tons of plastic are used. And you know, plastic has become a very controversial material in the meantime. And we have to just face that after hopefully 25 years, which is never guaranteed, but let's say 25 years, we have a lot of plastic to recycle. And that plastic will be completely soiled with undergrowth in the water, like slimy stuff that has to be removed. The material itself has become brittle over time and so on. So it has to be really down recycled. And nobody at the moment is considering to what kind of product it can be recycled. Definitely not to floats again. Next slide, please. So how sturdy wood is shows this picture. This is the inside of this wind tower that goes up to 120 meters, which cannot be built by steel because the foot part of the steel is over 6.4 meters wide in diameter, and that cannot be transported on the road anymore. So the idea with the with the wood came from that limitation of steel. And it looks that they are very successful. They are getting more and more traction. So next, please. So what is changing in the module area? In my opinion, only dual glass modules are long-term suitable for FSP floating solar panels with the current designs. With back panels from other materials, that is very risky because of the moisture, the high moisture content, and it's possible, but I am not very optimistic that they really will last for 25 years. So dual glass is definitely the safer solution. Hanwha Q-Cells has just recently published that they have developed a special module specifically designed for floating solar, which means water tightness and also electric safety. Interesting also is now in the US, in some startup company, the first roll-to-roll production of Perovskite on flexible glass has been successfully shown. It's already working, so I think this is just a matter of upscaling, and then we have large-scale roll-to-roll produced systems, but just something like 40 million for 4 gigawatt of production. So the capex is much lower, and also the production costs are much lower because there's very little labor involved in that. In my opinion, the future will be lightweight polymer-based OPV or perovskite modules, and I'm usually 10 years ahead of the curve, so you can expect, I have predicted that about 4 years ago, you can expect in 4 years, 4 to 6 years, we will see these polymer-based OPV and perovskite modules on the market. Okay, next slide, please. Next slide. Next slide, please. Yeah, that is Hanwha Q-Cells. Next slide, please. Yeah, this is the roll-to-roll perovskite on flexible glass production plant. It's very simple. It's like a newspaper printer. So that means the glass is flexible on a roll, and it's rolling through this device, and in multiple layers, the perovskite is put on top of the glass. Okay, next slide, please. Currently, there is a company in Holland we are cooperating with, and they are producing amorphous solar, flexible solar modules, and this is what they are currently doing. They are testing rollouts in desert areas and also on special roofs. Next slide, please. Here they have done an installation on oil tanks. You know, the top of oil tanks is not hard, it's not metal, it's just a coverage, and normal solar panels cannot be installed there, but this is very lightweight. It's just 2 kilos per square meter, so very light, and they can install it. Next slide. Next slide, please. Okay, 2019 was actually a pretty bad year for floating solar because we had heavy storms, and especially here in Japan, we had severe damages. So this is a list of the installation areas where the damage occurred. The reason was always wind. So being safe against wind is one major consideration you always have to keep in mind. I just heard yesterday that Chennai area had a very severe cyclone, so you are not safe in India from really severe weather, and we probably may see more in the near future due to global warming. So we had the worst one was the third one, Shintaku Tameike. No, that was not Shintaku. Yamakura Dam, the Yamakura Dam in Chiba Prefecture, that was really very bad. I talk about it, about some reasons why it happened. And even in China, there was one case, though it was never reported. Somebody found it on global Google Earth by coincidence and sent me the photo. So it's quite interesting. There was one in Huainan, and in China, there was one large solar installation that was ripped apart by wind. Next slide, please. Yeah, can you click once more? It's a video. Can you click once more? It's a video. Hello? I don't see it moving.
Just a minute, sir.
Oops. Yeah, on my side, the picture wasn't moving, so. Anyway, next slide, please.
It's damage of analysis, Yamakura dams.
Okay. Yeah, that's Yamakura Dam. So that was a result of severe typhoon that exceeded the specifications of the installation. And we had even a fire through a short. And that was the worst accident that has ever happened to a floating solar installation. Next slide, please. Next slide.
Just the damage analysis.
Yes, next slide, please. That was just a report that was given out by Kyocera, the owner of the dam. Okay, I tried to explain the reason a little bit. The floats were the typical one float, one panel constellation. And the problem was that the wind came from a direction that caught the installation from a weak point. Many people were suggesting that it was the mooring that was bad, but you can see here from the picture, the small one on the right-hand side, you can probably not see my cursor, but on the right-hand side there is a small illustration, and it shows that there are really a lot of mooring lines. So it was not really the mooring. So can we have the next slide? Next slide, please.
In next slide, sir.
Yeah, okay. Here you can see all the small blue lines are all mooring lines. So this was really well protected. But you can also see that to optimize utilization of the pond, there were a lot of segments that are interconnected. And there we had some weakness in the design. Next slide, please. Yeah, here you can see again, they had 420 anchors and 828 anchor lines. So the plant was very well protected from that point. Still, it was not enough. Next slide. Next slide, please. Okay, here you can see where it was ripped apart. It started in the corner. The wind direction is shown by the arrow at the bottom. Yeah, and it started at the corner, and at various points after one of the links was breaking, then the whole plant was breaking apart. Next, please. Next, please. Yeah, there we go. It turned out also that some weakness was in the connections between the floats. Some pins broke and some lugs broke due to the wind power, and that gave additional possibilities for the wind to act on the floating solar. Next, please. Yeah, here you can see there are some details where lugs broke and pins broke. And another special feature was that the wind actually rolled the whole plant over. You can see that on the left side at the bottom. Next slide. So there are strong forces potential forces on floating solar. You have to keep that in mind. So there was another one in Saga Prefecture. It's West Holdings, and they used a system from Kyoraku, which is similar to the Ciel system. Next, please. The same happened here. Next, please. Yeah, there we go. The same happened here. The floats broke loose and they were pushed onto each other onto the floor, and the system disintegrated. Next slide. Yeah, you can see here. There was the same reason the lugs did not sustain. Next. Yeah, so this is the Google shot from the sky, from the satellite, and there you can see that even in China, a large installation broke apart. You can see the panda in the center right. It's in China, this also broke apart. Next. Next, please.
Yeah, it's a materials.
Oh, okay. Yeah. Another point that you should definitely consider is material fatigue. It's called low stress brittle failure. HTP is a wonderful material, but it has one downside. It is relatively weak against bending stress. So if you bend, for example, a pipe or anything out of HDPE many times, it starts to change its crystalline structure, and it becomes brittle. And that is well documented in the polyethylene documentation in the research. Next slide, please. I hope that this video is working. One more click. This is another video. A very important one. I hope that works. Can you see anything moving? Anyway, yeah, there we go. So 23.7 million, 591 million over the lifetime of a predicted lifetime of a floating solar installation. After 1.5 million bends, the brittleness starts already. So you can calculate that it's not even a year where you will have material deformation. Next, please. So this you have to really consider in your design. This is also a video. Yeah, this is a reality of floating solar as it can be. It's not always the calm water that is shown in the catalogs. It's sometimes really rough, and especially now where people are starting to go offshore or into lagoons, there is a lot of design work to do, and that is not cheap, I tell you. Next, please. Yeah, what you also have to consider is changing water depths. This is in California during the drought, and you can see how different the water level is. If you designed your float too far to the left, you would be on dry land. So, next slide. Yeah, something you can already click the next slide. What looks really nice at first sight, and also under certain circumstances. Next slide, please. Yeah, looks wonderful. Perfect for floating solar, you think? But then comes the drought. And next, please. And all for a sudden, your nice floating solar is not floating anymore. It's sitting on the ground, and that does not look very nice. Next slide, please. Yeah, there you can see how everything is warped. You basically can throw most of this FTP plant, which became ground-based, you can throw away because you never have a totally level ground. And you will have problems in any case if it starts floating again. Not so easy. Do your research. Ask the people around, did you ever happen to see that empty or so? Do your research, very important. Next slide. Yeah, another thing are underwater obstacles, really harmless looking. Look very closely in the right upper corner. There are two little things looking out. Next slide. I have marked it here with a red circle so you can easier spot it. Next slide. Does it come? Yeah, it can look like this underneath. So when you do your research, don't forget to really look closely what's underground. This can be a former forest, and when it's getting, if the water level is getting down, then you have your nice floating solar installation sitting on top of these trees and also being warped and broken and so on. So next slide. Okay, the race to the bottom is a very complicated topic. I don't want to talk too much about it. I don't like it because, in my opinion, it is curtailing progress. Everything is so cheap now that nobody can really do R&D for large installations. So everybody is just copying each other, and that's not good for the industry. They have to make some money as well. So let's give us some room. So the race to the bottom is good for the consumer, but it's curtailing mid-sized companies and small companies to get into the game. Only very large companies have the power to sustain this requirement of going super cheap. And another point is, because they have to go super cheap, they are also cutting corners in terms of quality. Okay, next slide. I'm almost through. Sorry that it took so long, but the change of the slides was really a problem.
So, your conclusions?
Okay, yeah, my conclusion. Study your installation location very carefully. Use historic documents and experience from locals. Water installation has other rules than ground mounted, definitely. And so use the experience from boating that can help. Don't set sail when you're anchored. That's what floating solar is. It's anchored, and if you let your panels stick out too much, you have set sails. Always have 2 inches of water under the keel. That's also important. So remember, boating, it's always a good thing. Environmental concerns supersede yield optimization, and always be safe and not sorry. Thank you. Next. Yeah, and don't forget to join the LinkedIn group Floating Solar, please. Thanks a lot.
Thank you very much, Hans Judek, for a wonderful presentation. A lot of caution. Excellent. I mean, I think a lot of experience you have brought in, especially these few of examples in the last few years from both Japan and China. Now I'll open the floor. Maybe we will have about 3 or 4 questions to Hans Judek before we get on to the next presentation. So please raise your hand, or you can unmute yourself and ask question to Hans Judek. 3 questions maximum. And introduce yourself. Yeah. I can't see the person. I mean, somebody has raised a hand. Please go ahead. Yeah. Unmute yourself. Yeah.
Hello, are you able to hear?
Yes, we are able to hear you. Yes.
Yeah, from the presentation, it appears if you take into account all the parameters, to be on the safer side, to take into account all the wave actions and wind actions, etc., it appears the design will be very robust, which in turn call for a very high cost compared to ground-mounted solar. So how the ground-mounted solar and the floating solar will get compared in this scenario? Thank you. I am Bhaskar from Nuclear Power Corporation.
Okay. I understand that argument very well, but you see, on water we have different parameters. We have just to face it. Some people are using concrete floats. We have seen that in Kerala a year ago in March when I did a presentation there. Concrete floats are very safe but expensive. That's true. If you go for cheap, for example, one Chinese company was very proud when I mentioned that that 70 tons of plastic is necessary for 1 megawatt. They were very proud to say, oh, we need only 45 tons. Great. But the problem is you're getting also a weaker float. And I've shown you the stress factors that are on the lugs and on the floats. You are running the risk that your floating solar will not last 25 years. You have to, of course, consider that risk. If you have an area where you have not so strong winds, it's not a problem to build cheaply. But if you go to areas where you have strong winds, like now recently in Tamil Nadu, you have to take that into consideration.
In spite of it, like even in the ponds, during the drought, what will happen? The water level will come down very drastically. So in such a scenario, what will be your suggestion?
That is just bad research. You have to do the research in advance. You have to find out what has happened in the past with this water.
Thank you. Thank you.
Yeah, you have to find out what happened in the past with the water body. You have to ask people who are living in the area. You have to look at public records and so on. So research is very important.
Hi. Hello.
Yes.
See, myself, Ravindra from Karnataka Renewable Energy Development Limited, KREDL. We are planning to establish a 20 megawatt solar power project in floating solar power project in Karnataka. The problem is database, the water year database and rain is. Can you hear me? How many years data is? Hello.
You have to put your volume down. You have to put your volume from your speaker down. Otherwise, you have a feedback.
Okay. Can you hear me, sir, now?
Yes, very good.
Sir, we are planning to set up 20 megawatt solar power project, floating solar power project in Karnataka. The minimum water level, the consultant told that it will be roughly around 3 feet. Probably at the end of the dam, we probably will have water all the years. But what is the required minimum database you have to consider for 30 years or 25 years? How many years database you have to collect, sir? In irrigation dam site or water, any lakes or drinking water purpose?
Yeah, 3 feet is about 1 meter. That's very,
1 meter,
very
sir?
shallow. Sorry?
1 meter.
1 meter, yeah. 3
Okay.
feet. It's almost 1 meter. So it's very shallow.
Okay.
So the risk that you are running out of water is very high. You have to really do research what happens during droughts, and you have to look at the weather patterns over the last 30 years and see if you find somebody who remembers when this pond ran empty. Then you have to consider, is it possible to create a design that can settle on the ground without being warped and without breaking apart.
So it's possible to design such type of thing is possible.
Everything's possible. It's just a question of cost. You cannot do that cheaply.
Okay. In case of any emergency also, we can lift it from the ground level.
So if it's settling on the ground and you don't have really big mountains in it, which cannot be with 1 meter, and you design it accordingly that it's elastic enough to take up this this kind of stress in the structure, then you can design it this way.
And sir, one more question. Since they are all on the floating, I mean, these are all things on water. Is there any, you can compare to ground mounted solar power project in floating solar power project, any increase in the efficiency? Have you studied?
Yeah, that's proven. That's proven. You have to ask the University of Singapore. They have very detailed data that they have collected on a 10 times 100 kilowatt installation where they compared the different parameters. They have a lot of data. You should contact them, Singapore.
Okay. Thank you, sir. Thank you very much.
You're very welcome.
So this is Krishnan
Padam Narayan from
Tata.
Seki.
Sorry.
Yeah, this is Padam Narayan from Seki. I have 2 questions regarding the floats itself. You have shown some examples where you identified that wind is a potential culprit for the perils of the floating solar, and
yes.
The pin and the lug is the potential point where the junction got ruptured and floats become independent and roll over the other modules.
Right.
So and alternatively, you also suggested that wood can also be replaced as a float. SDP can be replaceable by woods. But
it's an interesting idea. I don't know. Up to now, it's a question of cost, but it's possible.
Okay. Yeah, but what I can think of it, I mean, there has to be a connections always, like the pin and lug arrangement sort of a thing would always be there, which is always given you a potential threat where the link can break and things may go wrong when there are strong winds and other things. So how would you suggest that these should be linked in more appropriate manner? Because most of the design what we seen for the floats, I mean, what you have shown or what we have come across, do have such pin and lugs which are I mean outside from the base float structure. So I mean guide into those floats which can be robust enough to contain solar modules in a relatively higher wind conditions?
Okay, I don't say that it won't work. If they, for example, have enough play in between lugs and tabs, some of the motion may not reach actually the material of the float itself. But if you have bending stress on it, there are plenty of research results on bending stress brittleness. It becomes brittle over the years, and that's just a fact of HTPE. In case of wood, I can tell you, I bought as a student, 1971, I bought a 25-year-old wooden airplane, and I restructured it, and I refurbished it, and in about 1,000 hours, and it's flying still today. Can you imagine that? Wood is not deteriorating if it's not rotting. And against rotting, the guys in Sweden that are building the wind towers, they say there are multiple possibilities to long-term protect the wood against rotting. So if it's not rotting, there is no fatigue in wood. The connection, that has to be considered, but it can be very sturdy. It can be metal, and it can be a ring around the pipe out of wood that is distributing the stress. What I see at the current design is that the stress is on a very small area at the foot of the tab, where the tab goes into the float, and that is a critical point. And I'm really curious how that will look in a couple of years.
All right, sir.
Yeah.
All right, sir. Definitely.
Sorry, we are running out of time. Only one last question before we have the next presentation. One last question. I think I can see solar APEPDCL.
Sir, this is from Solar APEPDCL. So what I would like to ask is, what is the cost comparison of floating solar plant versus conventional plant, which is situated on the ground?
Yeah, the last figures I read, I have published that on in the group just recently. There's a very good article that a friend of mine wrote, and there he says it's between 10 and 15% than ground mounted.
Okay, thank you, sir.
Yeah. Thank you very much, Hans Judek, for a wonderful presentation and also for responding to the queries. If there are more queries, you could post it and we will try and get a response from Hans Judek. And I would also urge all of you to join the LinkedIn. I mean, he has been referring to a lot of interesting results and studies and all that. Thank you, Hans. I mean, and then take care of your health, and we look forward to seeing you in India very soon.
Hopefully, yes. COVID is really, you know, our one plant that was scheduled to go into operation in May has not been even started. So that it's really holding back a lot of activities, unfortunately.
I know.
So let's hope the best.
Yes. Thank you very much, Hans. Yeah. Thank you very much.
You're very welcome.
Thank you. Now we have the next presentation by Mr. S.S. Mishra. Mishra ji, are you there already? Can I see? From NTPC?
Yeah, I'm here.
All right. Okay, sir. Thank you very much. Okay, I'll just make a short introduction, some few lines. Mishra Saab is the General Manager and Head of Department of Renewables, Renewable Energy and Engineering at NTPC. He is a passionate power professional with electrical engineering background with about 3 decades of experience in different areas of power sector. He has power plant design, substation, power system. He has also contributed for the conceptualization of Anantapur 1500 megawatt, Pavagada 2000 megawatt. These are some of the largest plants which NTPC owns in the country. He is also the chairman of the committee of BIS on electrical insulators, accessories, and he is one of those pioneers in the renewable energy sector as far as NTPC is concerned. Mishra Sahab, the floor is yours.
Yeah, thank you, sir. Thank you. I'm sharing my presentation here. I'm trying here. There was some problem earlier. Let me try it out. Is it visible, sir? No.
No, sir.
Okay. I think there is some issue.
So shall I operate from here, sir? Because
I
we
think
have already.
that is better कि अगर वहां से आप कर दें या मैंने एक बार ये यहाँ पर आया 1 मिनट में ट्राई कर रहा हूँ. You are trying to operate?
I will do from here, sir.
Okay. That's fine then. There is some problem in sharing. Sorry. Yeah, next please. Good afternoon, everybody. Yeah, as you see, floating, Mr. Hans he has covered a detailed one, but I will give a different perspective because we being a utility, I will give the utility perspective. What are the issues, what is the challenges, opportunities, and the conceptualization, how we can bring down and face those challenges. That's the basically motto here. Not going without going into the very detailed one. I will give a very say the practical aspect and the utility aspect which need to be cared. If you see the floating, what is we see something is floating on the water, then we may have substations also, power small substations of say 33 kV packaged one, or otherwise maybe floating. So you can imagine a system where you are running a small level substation, transformer, inverter duty transformer, switchgear, SCADA, everything on the ground comfortably. We are tuned to that. But suddenly if you find one day that, okay, this cannot be placed on ground. So I have to go on, I have to float this in the water. So the conceptualization, the entire system gets completely changed. Means you need, then what you need a flotation system which will take care your substation very near to the floating system. Means you have to load your transformer, you have to load your inverter, you have to load your electrical system, switchgear, SCADA, everything together. So that's the whole lot of concept and lot of design issues, and the ecosystem development is very important. Ecosystem development goes to that. So that's very challenging, interesting, and very, very exciting also. Next, please. Yeah, this is just a glimpse of actual site project Ramagundam. It is being and it is under execution. It's not on paper. 100 megawatt. This is AC. This is 100 megawatt AC. So DC wise, it will be somewhere around 140 or 150 megawatt solar project. Here, the water. If you see that there is a water and just you carpet it, it's not. It's not at all like this. The whole thing is we cannot imagine simply carpeting on the water by some flotation device and go to that. No, it's absolutely a lot of design, conceptualization, a lot of say simulations go through that. And that simulation goes that why it is shown that in spite of a lot of continuous water, we have not carpeted. We have made the very blockwise. You can see a rectangle sort of thing. So these are block design. We cannot imagine like ground mounted that you have a continuous say arrays, most likely say 10 to 15 megawatt minimum block size in a continuous fashion, and there is no restriction on the say footprint wise. Here there are issues, there are challenges, there are technical reasons why you have to restrict your design with the block, and what is the block concept. So here in Ramagundam, of course, we have conceptualized with BHL is EPC there. We have conceptualized with 2.5 megawatt. It's slightly lower, but it is we have conceptualized that. There in Ramagundam, as I have said you, it's an entire substation itself is also floating, and it is very exciting and challenging. That this will be basically a model plant, I will say, that all the elements of floating system, electrical system, and the issues what a floating system can have. I think after construction, this will be really a marvelous and model plant. What all design, conceptualization, issues, safety aspect, everything, how it goes to that. Next, sir. Next slide, please. Yeah. It is a data. I don't think there is much of a say growth worldwide, and probably the way here we are trying to push floating solar concept, we may exceed many countries in coming time. That's all. Next, sir. This is a simple data. Everybody may be aware. Next slide कर दीजिएगा. Yeah, इसमें थोड़ा सा full slide नहीं हो पा रहा है. इससे कुछ issues है क्या? Or I am not able to see that full slide, something like that. Okay. So next कर दीजिए. ये भी एक data है. We have today we have only that slide was only depicting that basically today we have only 2% of the say normal conventional ground mounted system. Only 2%. So, but in the years to come, because of the say land or issues, people are trying slowly, and NTPC is basically a prime mover. And if you think, if you are aware, we have already started floating solar, and 235 megawatt is under construction. This all I'm talking is basically AC capacity. And this is already under construction in our, as I have shown you in Ramagundam, and then other projects in Kerala. It is a very exciting project, 92 megawatt Kerala, and next two projects are a small project. This Simadri, those so total projects capacity and everything is on different type of say water bodies. In Kayamkulam we have a altogether different thing. In Ramagundam we have a completely different profiles. In Simadri we have a completely different thing. It is a totally artificial reservoir. With a big challenge was that the reservoir is already sealed. If you know, there is a liner, especially thermal plant, they have a liner, so we cannot anchor it within the reservoir periphery. That's a big challenge. So that also different varieties of plants we have faced. So if you talk about Mr. Hans has talked very interesting point. I do not know how many of us has appreciated, but the floating solar, if we say the energy, I am talking about the utility perspective and all. He has taken a word that's very nice. It's the Seri Singapore. This is the only, perhaps to my knowledge, maybe other university could be there. They are doing some research that what the design of floating system, how it matters, how it is bringing, how it is pushing, that which type of design gives how much of energy. So the energy yield from a floating design, floating solar project, entirely depend on the flotation device design. Means what is the cooling system, what is the angle of installation, and then of course the type of the project, the velocity, wind velocity, and entire thing. The meaning thereby, if you see the PVS's energy estimation calculation, we have certain coefficient UC and UV. So this UC and UV is for ground mounted, more or less it is very, very standard. But if you see the floating solar system design, this particular thing, in my opinion, there is a lot of work need to be done on this evolution of this constant of cooling. This is the cooling basically. So this cooling, if you devise, say, some manufacturer offering certain type of design of floating system, they should also get certification. In my opinion, I am advising a lot of floating system designer that you get it also certified from, say, Singapore or any other university in the world, that what is your, say, USP, means what is the coefficient, these coefficient. If as a utility I am trying to calculate the energy yield and the economics of that plant, then I should be able to do that quickly. Next, sir. Next slide, kariega. Yeah. So this is basically another part of that, how the really cooling gets affected. So the yield from the floating design, it's not that every design will give you a different thing. If you have seen here you see the backside of that have a regular wind flow over the water. There is a gap. Maybe the angle is different, but many flotation device and all have a completely packed plastic. But if those plastic also, if there is a contact between water and the area space, basically it's a vacant area space. How much is the vacant area space? What is the, say, air circulation methodology? So different designer has a different concept. One design, second design, third design. So every unique design will have a different thing. So how to monetize this? Again, I am repeating here that this should, then the floating system designer should come forward and they should also get this certified by independent institute, very little institute. I think there is only university, say, Singapore, who is doing this work now. Earlier there was almost no institute, to my knowledge. Maybe there may be some institute anywhere, but to my knowledge now it is only one institute. So we advise all the floating system designer to get this certification. Like why you should get it? Because if you see the module type, module why we get certification, means the design efficiency, everything comes together. And those parameter as a utility, we use it as a LCOE, life cycle cost of energy. So ultimately, a lot of guests here were concerned about what is the cost and benefit analysis. So if you have this fine-tuned data, then I can have, of course, NTPC has a different type of bidding system, and we have a very unique concept of evaluation. We don't evaluate on megawatt basis. We evaluate on energy basis. That's a different concept. But this I advise many floating system designer that you please carry out this, and this will help us also to get our economics done. Next, sir. Yeah, so this is just a glimpse, sir. This is a very simple scene. That there is a water, you make some kind of flotation device, link it, and just place it, leave it. No, absolutely not. The lot of design concept goes to that. If you see about the simple floater also, this floater will have a complete design concept of buoyancy. We have the what should be the thickness, what should be the optimum thickness, and where how much thickness should be there, whether it should be uniform, whether it should be non-uniform, which place, how much. So a lot of design goes to that. This manufacturer does this finite element analysis and very renowned software ANSYS. They take off help of ANSYS and then design economical and reliable floater device. So that's this is the what you see the blog do not come just like that. It comes with a lot of science on that. Same thing if you go for a blocking system, means you correlate so many floater together and make a block like say 2.5 megawatt or it's a 5 megawatt block. So those block, what it is basically, it is creating millions of joints. How one is connected with other, and then how this block concept is behaving as a structural design. So then what you need is you have to take care of what is the wind effect, what is the wave, if it is a reservoir, long big reservoir, what is the wave effect, what is the wind effect, and how these forces are, composite forces are getting transferred on the links and joints and every point, and how to restrict that. So it is very challenging that anchoring and mooring system design for a floating system is another challenge. So that challenge we have to do with a lot of design analysis. Here I just want to mention one point here, that we have not a very wide, say very large pool of specialists in this system. We have to develop a good ecosystem who can develop this customization. Maybe piecemeal and all CFD as a unit, it may be available, but finite element analysis as a technology is available. This all application part. But when you apply to a floating system design, there are a lot of say issues comes forward. Say the Moses or OrcaFlex, these software application to the floating system design, and that to the type of floating system design that is required to be done. So the ecosystem means we have to develop so many specialists who will take care this design aspect when we design a plant. Floating is a one unit, but when you design a block, when you design a whole plant, the whole system gets integrated and the whole system need to be safe. As Mr. Hans was indicating, the threat and this thing, the how to make the plant safe. So these are the design philosophies that you have to follow. You have to contact a specialist. You have to get them on the roll. Maybe through consultants, maybe through as a specialist body. Here we will urge through this forum that even IITs and many academic institute, or maybe engineering institute who can come forward and make a customization of this ecosystem. Maybe specialists can be developed for floating system design. Maybe some academic institutions can put up a course. This is my just I'm telling because we have experienced a lot of lack of experience, adequacy of experience, and the application part. Knowledge is a different thing, but application is an aspect which need to be developed for if we want to grow this floating system in India. Next, sir. Yeah, this is a simple flow chart. I will not go for that. How the flow chart, it's not a simple thing that you just go and stack it and do it. There are steps we have to follow. How to start, how to do the array. You then go for next wind aspect, then you do CFD, then you do next is the structural design, then you design the anchoring and mooring system, then you check back the accuracy, then you check the buoyancy aspect, then you check the say substation, if you have to float the substation, then you have to check the say balancing aspect of that. Transformer is placed in the water on the floating system. Your substation, your switch gears, everything is floating. So this entire mechanical, electrical, and the complex this design aspect you have to see, because every point you have to anchor and moor. Otherwise, a simple wind will take away the entire plant, and everything will get destroyed. So the whole what I wanted to put a point of view that the perception of this floating power plant goes with a lot of science is there, and we have to address all those design aspects right in a systematic manner. And not only that, we have to go adopt the economical design, and that economics goes with a lot of equipment selection criteria, what to select and how to select and what design to select. This is for a simple example I'm giving. If we consider as a floating system design with anchoring and mooring certain say level of cost, so I have to reduce the footprint. So if I have to reduce the footprint, then I have to go for a high efficiency modules, maybe 500 watt, and we have are adopting 500 watt also with the latest design. And next maybe we have to go for say 640 or 700 watt. So this aspect is also to be considered when you go with the economics of that, economics of whole of the plant. So that economics basically will give you the LCOE, better LCOE. So in addition to the energy yield calculation, where also the design of floater matters, the yield, here also there is a design of equipment, design selection of modules, selection of say type of block, size of block, everything together, cost of anchoring mooring system. This whole conceptually is linked to LCOE of the project. Next, sir. Yeah, so the challenges I have by and large, I have told that the more and more the data you will give that bathymetric, then not only a simple bathymetric, maybe if it is a large reservoir or is a say river fed dam reservoir, then you may have to go for a wave bathymetric also. Then geotech and surrounding bed design, how to do that. Of course, Mr. Hans has very rightly pointed out that you have to take care the all research part, means the water flow pattern, water flow, whether it is getting dried up or not. Some questions were there that whether floating system can work where water goes off. Yes, the answer is yes, because there are a lot of design, but you have to say upfront that because a certain design concept has to be taken care before that. Otherwise, you will land up in problem. It will not lift again. But suppose the water goes away, it is dried out now, it will sit on the floor simply, and when water comes back, it will go up. But for that, you have to specify, you have to upfront, so that the whatever cost is to be borne for that, whatever design concept is to be followed, that needs to be followed. There are say specialists on that. This our quant solar in India, they have spread a lot of they have set up a manufacturing plant also, and they because of their knowledge bank earlier, they are also fulfilling all those requirement which is required. But the point here is we have to develop, they are very limited manufacturer also. It is available, very little manufacturer. Because if you go for a larger plant like 100 megawatt, 200 megawatt, you will not find that the product is available, not like a normal conventional solar plant. Because you can imagine a floating device numbers in millions and millions. Manufacturing of that cannot be, say, imported. So this is one aspect that the floating solar project is a force make in India. We have to make here, otherwise the whole economics we cannot meet. But we cannot transport air. The floating device is a hollow thing, and then we cannot transport. The cost is very high. So it has to be made locally. It is a positive part, but the say capacity augmentation, the design aspect, the say skill aspect, And those, every quality aspect, everything, whether it is floating device, whether it is plant, whether it is other material, it needs to be addressed. Partially and fully, Mr. Hans also has indicated that this design is to be taken care. It is possible, but it is with a design. You have to, in the design stage itself, you have to take care and you have to specify and you should get it. So today the supply chain, the whole supply chain, the whole conceptual, the integrated supply chain is not available. We have to develop here in India the integrated supply chain of every item. Skill development, say the analysis part, whether it is say floating, economical, say flotation platform, substation, where you can place your substations, and then the skill and knowledge of anchoring and mooring system of different design. Next, please. So the whole aspect here, you have a good amount of financial gain, and then you have good amount of points also to be taken care. How to take care the the safety aspect, environmental aspect, O&M aspect, and the challenges of long-term sustainability. Financial, definitely there is no, in India we know that we are very cost sensitive. We have very cost sensitive market, but cost sensitive market we have to consider these. We cannot compromise on the basic conceptual design, where the system must work for say 25 years, and it should give us the whole economics also, the LCOE plus this, the combination of these two. So one side we have a financial aspect we have to take care and go to a minimum cost. Another side we have to take care safety, plant safety. Safety means plant safety, and the design aspect and environmental aspect also, and it is feasible. There is no point that we say that it is not possible. Next, sir, do you have another slide also? This is only data. आगे जाइए. This is simply a data. आगे slide कर दीजिए. Next slide. Yeah, I think there was a question on the cost and all. We have done a simple basic fundamental analysis, and of course the project, you cannot, there is no simple one formula that this cost is say ground mounted, this times is the formula. No, there is no simple formula, but in a generic manner, in a typical manner, if we have done some kind of analysis based on our data, based on our experience of running project. We are already constructing project of 235 megawatt AC. So based on that, we think that it is ranging from 7% to 20%. It definitely is on high side, but if you monetize the saving of say water, or say water in terms of say plus side of the environmental issues, and then the development, and then these floating system is basically contributing in making India, because the entire thing has to be made here, otherwise it is not possible. It cannot be imported from anywhere in the world, because the transportation cost is very high. So the whole formula, we have given a simple arithmetic here, and the cost is there. But still, what I want to give a message here, every project in floating system is a unique project. Kindly note that every project is a unique project. Means we have to do the total detail analysis, right from the say reservoir data analysis, the water variation, water depth, and then of course in terms of bathymetric survey, then the bottom geotech analysis, what is the strength, whether this anchoring and mooring is possible on the bed or on the say bank of some big reservoir. So every project we have to do a detailed analysis, then only we can come to a conclusion and we can propose that this project will have this much of LCOE. So though show, but the typical figure is 7 to 20%. If you see the cost of the say project, if we are handling say 10 meter up to 10 meter, 15 meter or something water depth maximum, so that may not pose a challenge. But depth is one part. Now comes the wavy nature, then the wind velocity and the wave effect of that, and then the surroundings. Then of course the place where you have selected, what is the insulation, solar insulation. So those solar insulation, if you are handling a high solar insulation, probably you can compensate these cost. But if say the wave effect is more, then we have to invest more on to take care of anchoring, mooring design, and the block design will be unique, and the substation floating system will be unique, and then we have to take it to a power evacuation system integrated with the grid. So the whole typical, this is the figure, that's what we have done analysis and given you a typical figure. Next, sir. Yeah, so in basically summary part, what I want to mention, there are a lot of opportunity here, definitely, because we are promoting through this floating system. What we are promoting? We are promoting high efficiency, because high efficiency, say in terms of module, if you go for high efficiency and all, you will save better cost. And then floating system, we have to do make in India, otherwise it is not possible. So we are opportunity. You are promoting efficiency, and we are forcing by say adopting this, you are promoting make in India also. So then you in hydro, probably this is very difficult question, and difficult question to maybe theoretical to answer, but practically how much it is possible, it is to be seen. There are literature worldwide available that why don't we make a complementary part of hydro with the floating system. But say hydro, wherever generally we have, wherever we have hydro, at least in India, we have a poor solar insulation. So if you have a hydro with a moderate, good amount of solar insulation, we can probably use of that hydro reservoir, of course, with a lower or moderate depth wise. Otherwise, there also the point is which area you have to select. The very important aspect is which area selection for a floating system, which area you have to go, so that the plant safety, cost, economics, depth, and the wave and the water velocity in all seasons. Not only it's not that one season, in all seasons it is moderate. So the hydro part, if we have a hydro with say good solar insulation, probably we can complement, because the entire infrastructure is available. You don't have to create a separate evacuation system, power evacuation system. So probably you can integrate this as a complementary things. But at the same time, probably it is to be examined with respect to the say energy yield, and of course the type of reservoir, which type of reservoir we have. If it is very depth, wavy, then it is very challenging. If it is a moderate and flat type of reservoir, or we can do some pocketing type where these effects are minimum. There is a lot of study we can undertake and through this thing, and then come to a economics. So if you see the opportunity, there is a large opportunity. Save water. There is a chart here. I don't know how many of us have seen. I've recently seen that the water evaporation rate in India is exceeding very large, very high. So if you go with a simple calculation of water evaporation rate of India and the surface area what is covered, so that gives almost 40% saving of water. But it has not been established on paper or on the say scientific aspect. But if you go simple with the water evaporation rate, what government publishes, if you go for that, the water saving is substantial. Water saving is there. So that is a lot of opportunities there to harness those. Of course, we in thermal plants and all, we have a big reservoir. We are we are converting all the reservoir into with the floating system. We are saving water also. and we are taking power also from that. So that's a basically dual advantage of that. We are saving water, means helping environment also. As far as environmental challenges are concerned, there are a lot of, I have seen certain literature that gives a point that what will affect to flora, fauna and all. If you see the real aspect of that, I have told this in some of the other forums also, that if you see, that's I have told you in the initial glimpse of one of our project. If you see, it is not never been a carpeting cover, no. So by design itself, you see, we are not using the entire carpet area and covering that with the plastic, no. So by the block design, by leaving the intermediary spaces for anchoring mooring system and those aspects, a lot of space anyway we are leaving. Even with that, there are some other designs with floating system, which are basically mounted on a structural sort of thing, which will cater more waves, and it will even cover less amount of water. So wherever you have environmental concerns to be seen a little cautious, I think there is no environmental concern in terms of covering those water and creating issues, something like flora and fauna, what I have seen in some of the literature. Absolutely, in my view, this challenge is not at all there, because we are not carpeting. I am again repeating this aspect again. So the water saving and challenges, what I am just summarizing. Don't take it, as Mr. Hans was also telling, don't take floating solar as a simple plastic and then cover. No, a lot of literature, science, knowledge, design aspect you have to apply, get it for a comprehensive design. I'm not saying it is impossible or it is extremely costly. No, the point is you have to take care the balance of these two aspects. The balancing of, you have to take care anchoring mooring design, floats design, and the energy held system, how, and the plant design itself to minimize that. So anchoring mooring constraint that definitely we have with say large amount of water variation, it's a challenge, because you can imagine, so water level goes high, then you have some depth, very high depth, then water level comes down, you have very little depth. So you can imagine the system of anchoring mooring, how complex it will be. But technology is available, we can it is possible to do, and we have to take care during the design stage itself. If it is a wavy thing, more of a wavy, then we have to do CFD analysis. We have to do this and a lot of structural analysis and anchoring, mooring, supporting system. Everything is to be nicely designed. So that's it. There are opportunity. There are solution for challenges also. One aspect and what we have experienced is SDP material. So there are SDP material. There are a lot of chemistry. So chemistry in our academic days also, we have seen there are a lot of equations, and it is very complex. It's not simple. So there are a lot of chemistry inside, and with the design type of material and the to take care of the UV application and the long life of say 25-year and beyond life, it is to be very much taken care in the design, in the testing aspect. We along with we have taken help of CPET and helped basically manufacturer that how we have to test the product, how we have to test the product to ensure its life, its quality, its mechanical and its aging aspect. It is not, you cannot find a simple solution for a floating system. There is no standard which integrates everything. No, that's the issue. That's a challenge. But there are solutions available and expertise available at various corners. So we have to correlate and collect all those corners and give a right product and reliable product. This is what I have to present. Thank you, sir.
Okay. Thank you very much, sir. Many thanks, Mishra sir. We will just take 2 questions. I mean, because we are running behind schedule now.
Yeah, sorry, I have taken time. I think.
No, that's okay. That's okay. No, we understand the problem. Yeah, just 2 questions. I mean, you can unmute yourself and introduce and ask the question to Mishra sir. Yeah.
Yeah, actually, I would add a comment if possible.
Yes, Hans. Yeah.
You have shown in your presentation that aging of material is to be taken into consideration, especially that HTPE has not been well researched what the aging process is. In fact, it is. There is a lot of literature on the internet that you can find, especially for pipes. For example, if you have a HDPE pipe under a road, you have a lot of pressure from trucks or so that is changing. And these load changes that have been quite well researched. I just wanted to mention that. You find it on the internet.
Yeah, I know. I know, sir. SD pipe, we have a lot of literature, but I was pointing out this basically as a utility because if as a user, as a utility, if I want to assure my plant for all pipe, it is available, but there are a lot of other float design. How to see and check, and with the design aspect, with a taking care of the aging and what type of material, what type of design mix, and who will guarantee. So where is the certification utility? Is any certification utility is available in world? Who will certify this product that, okay, this product is certified for this? There are other designs. Pipes, there, you are right, there are pipes, there are a lot of literature available. We have also tried to investigate and consultate, and basically what NTPC has done is a very interesting thing. We didn't know anything about floater initially. Then we collected information from all these worldwide manufacturers and tried to create a specification. And to, by collecting, knowing, increasing our base, and then as a user perspective, as a utility perspective, and then floated a specification in the market. But today, based on the experience, what we will having from the plant is there are a lot of issues also which we have to take care for different type of design. That's what you are very right. Literatures are available, but there should be agency also should be available who will certify this product. Like module, we have agency available, but we have an internationally recognized third party certifying agency. In floating system, we do not have such system. Knowledge is there, but in pockets, in institutes, in separate places. It has to be integrated. That's what my point was.
Yes, thank you, Saab. I mean, yeah, I think the point is well taken. I think you emphasized on make in India, especially in the context of, not importing the floaters. That's going to be expensive. Thank you very much, Saab. Mishra Saab, for a wonderful presentation. And if there are any questions, CBIP and IGEF will come back to you from time to time, requesting your expertise and guidance. Thank you, Mishra Saab, once again. And then we will move on to the next presentation. This is from Mr. Andres Franco Zimenez. Yeah, he is the CEO of IC Genere, the pioneering company in floating solar systems since 2008, when the first floating solar system was installed in Spain. He is leading the national international growth of the company in utility scale and self-consumption projects while continuing innovating by creating new and better versions of the IC floating. He has worked in Aquanima, a procurement services company owned by Santander Bank, where he led its growth multiple times. Prior to Santander, he worked in McKinsey & Company, a very big consulting company. He has a background in computer science and holds an MBA from the Kellogg Graduate School of Business in USA. The floor is yours, Mr. Andres.
Well, thank you very much. Hello, everyone. Thank you for your time to be today here in this presentation of floating solar. I've been listening very carefully to what Hans and Shiv have been saying, and I am, in many of the aspects that they have been saying, I'm completely in line. And so in this presentation will be some of the things that are similar, and the main objective of my presentation is to share with you our real life experience of 11 years in floating solar, and what are the things that we have learned, what are the challenges, and how we have been solving those challenges. Let me start explaining that IGEF started in 2008. It has been 12 years working only in floating solar, and this is the first system that was installed in 2009. This is a system, 300 kilowatt system, still operational in the south of Spain, and we have learned a lot. Some of the things that I have mentioned about the aging, the wind effect, fatigue of the materials. This was our first version, and I will explain what we have learned and how we have been evolving until the fourth version of the system that we have right now. And as it was mentioned before, there's a lot of theory models, but real life, especially in floating solar, is much more complex because you have more factors than in ground mounted or in rooftop that are hitting your structure and your floating solar plant. The company, IGEF, it's a Spanish company. We are doing all the manufacturing right now in Spain following European standards of quality. And what we have been doing is creating an ecosystem of companies that work with us in order to implement the full solution to the end client. And in India, we are present in the market with a partnership with our partner, Autonic, who is a local solar EPC company, who is helping us to sell the system and the design to the clients that are interested. Autonic has already been for 35 years in the market, working in EPC, in rooftop, and in different types of solutions. They provide the local support, the market knowledge. We are also working with them in establishing local manufacturing in India to continue optimizing the total cost of the system, even though our logistics, you'll see later, is very efficient compared to other technologies. What are the three things that Easy Floating and IGEF provide to our clients? We do the technical design of the floating solar structure as well as the anchoring and the mooring, because those two factors are key. And every project is a different design, taking into account the specifics of the site and the specifics of the electrical design. We manufacture all the floats components related with the structure and the anchoring and mooring, and then we also support and do the training to the team that will be doing the installation on site. We send engineers to teach them, but we don't do the training. We have been doing something a lot in optimizing the installation of the system, because that's an added cost that if the system is too complex, the numbers will not be as competitive. And please bear in mind this, we don't want to spend money in logistics or in installation, because that means that is less money that is being put in the structure. And the important is that the structure will last and that you put enough raw material, good components, so that the system will work for the 25 expected years. So this is an example on real life design in a 50 megawatt in Singapore. Some of the things have already been mentioned. Even though it's a 50, we don't build a big island. We need to separate the islands so that they can cope with the fatigue and the mechanical stress. We optimize this also from an environmental point of view, leaving enough space so that there will be air and light that it's getting below the surface of the water. We will optimize the system with the inverter and the electrical configuration to optimize the cost of the installation, the cost of the evacuation of the cables, energy losses, together with our client. On the anchoring and the mooring, how to cope with significant water level variation. And here you have a design where it was possible that the reservoir would get empty. Sorry, just wanted to check with you. Are you seeing my presentation?
Yes, we are able to see the presentation. Yeah.
Oh, sorry, no, there was a comment that there was a problem. Okay, so if anybody has a comment, please refresh. So I was saying the anchoring and the mooring and how to work in challenging conditions, and we'll talk about a special partnership that we have with a Swedish company called Cflex that help us manage those complex environments. And also how to put the electrical components so that there will be enough buoyancy and stability for workers so that they can do the O&M task without being in touch with the water, because water and electricity, people don't like it too much. So let me share what are the 6 challenges that we have seen in our 11 years of experience in the first installation. They are around the adaptability and the significant water level variation that some reservoirs have. Then the cost of the logistics and many air being transported and volume, not for weight. Then on the installation needs to be done in a cheap way, that it's very scalable, that workers don't need a lot of experience. The maintenance, this is becoming more and more important. In fact, CIRIS, the Solar Research Institute of Singapore, after their test bed, one of the 3 things that they concluded was that safety from the O&M in the test bed that they did was not good enough. You are not allowed to go there to step. They don't even do the cleaning of the panel themselves. They have outsourced that because they have some small incidents on accidents with the stability when they were doing the cleaning by themselves. So maintenance should be easy and safe. Then to be friendly with nature whenever there is nature. And the final challenge, which for us is the most complex one, it's how to resist nature. And we have talked about this. It's more complex floating than ground mounted or rooftop because you have the sun that degrades slowly the material. You have the wind load, but without the same support that you have in ground or in roof. You have the waves, and I'm not just talking about the 1 meter wave. I'm talking about the 10 centimeter movement of the water that creates fatigue in each of the components. And when this is happening hundreds of thousands of cycles per year, that creates significant fatigue. The structure will be different in the first year and in the 10th year and the 20th year. There will be changes in that. So it's not possible to have the same situation working. So you need to cope with that. And there are other things like snow or even animals. You know, we have seen pictures of crocodiles going on top of a floating solar plant, doesn't have enough buoyancy, the panels are submerged. And this is what we have seen. And unfortunately, we also have the real life examples of things that are happening in the world. These are some of examples of things in the recent years. None of this installation was older than 4 years. In this case, there were components that failed. There were massive damages, but you can see here other damages in irrigation reservoirs, not big lakes. So strong gusts of wind coming and breaking the structure and the panels. More examples of these type of situations, mostly in Asia. And you can say, well, yeah, it's because it's strong winds. No. This is in the Netherlands, June of last year. And you can see that there's in the middle of their businesses, houses, strong gusts of wind came and flipped the floating solar structure like a pizza calzone. And you see more and more of these examples. All of these are the public examples. And there are more that there are no pictures, but we know of. And why is this happening? And there are 2 things that we believe are the key factors. First is the thickness in the structure. Remember, this is a structure, and sometimes clients, they confuse that the things are floating and that it's a good structure. And it's 2 different things. Of course, it needs to float. But if you put 10 empty bottles of plastic below a PV panel, it will float. And it will probably float for 1 month, 6 months. But that doesn't mean that it's good from a structural point of view. And one of the key things in the structure, apart from the design, you can think about is the thickness. If you have a house that the bricks are very thin, or in ground-mounted system, if the metal bars are only 1 millimeter, you know that that is going to bend with the weight of the panels and a very light wind. And here you can see, as Ivan mentioned, there are no standards. So for clients, it's very difficult because every company says this is going to work, but you don't know what to compare to. And here you hear an example of a Chinese manufacturer that worked with 1.5 millimeters, a French manufacturer working with 1, and our system that is working with 3 millimeters. So thickness is very relevant because the higher the thickness, the more
sturdy and robust will be the structure. And the second thing is the significant wind load that is created and the forces that are put in the structure. Here you have a comparison of our technology that is now at 5 degrees. I know many people say, well, 5 degrees produces less energy. And yeah, I know it produces less energy, but floating solar is not just about maximization, because you need, the other plant that you saw, they were producing a little bit more energy, 3, 4, 5%. But imagine after 4 years, massive damage. Is that what you want? That, well, this is going to break. So that's why we have reduced it and with 5 degrees, and we have closed the back of the panel to reduce the sail effect that Hans was addressing. And this is one of the critical things. It's not about, when you compare the CP factor, the wind load force in our system that is around 0.48 to other systems that are at 12 degrees and that the back is open, the CP factor goes up to 2.1. You're talking about a 440% higher wind load. That's a lot of risk. And if you think that more or less the materials are similar, different combination of HDPEs, and you saw that the structure, the thickness is lower, you are buying all the tickets to the lottery so that your floating solar project will be on the news in 2, 3, 5 years. It's not going to last those conditions. So, and there are other challenges related, as I was mentioned, with the significant water level variation. So let me talk about how we have solved those challenges. I'm going to skip this and start talking about how we have evolved and changed our technology. Here you can see the evolution since the first system where we were doing a combination of plastic and metal. It was at 10 degrees of tilt. The floats were closed. The floats were connected directly between them. And for the first 3 years, there were no problems at all. This installation worked flawlessly. But after the third year, we started seeing issues like small puncturing in the floats. And when the engineers started analyzing, the puncturing was happening where the metal was being close to the plastic. And they saw that because the water is always moving, it creates very small friction between the metal and the plastic. And again, when this happens thousands of times, it creates erosion. And because the movement of the water, you have the two materials in touch, creating that erosion. And at the end, what's gonna fail first, metal or plastic? Well, the plastic. So we started eliminating all the metal components because we saw that in the long term, this is going to create problems. Other things that we saw, for example, the connection between the floats. They were initially connected through ears. And we saw that there were white lanes appearing in the corners of the floats. That's an indication of fatigue. Like when you bend a plastic car, it doesn't break, but it appears the white lane. So we changed, and now we don't connect the float directly. We connect them through a special connector that is not made from HDPE. It's made from nylon and fiberglass, because that it's able to support, it has some elasticity and flexibility incorporated into the material to withstand that type of situation. And we have been evolved. You can see here some of the changes that we have been doing, especially drawing conclusion from the real life experience of the 11 years of the installation. This is the technology that we have right now, where we have 2 floats supporting 1 PV panel to increase the buoyancy of the system. We have put a lot of relevance to the buoyancy. For example, the secondary floats, they can sustain 157 kilograms per square meter. We use HDPE as the main source, especially HDPE with additives against UV radiance and antioxidation. And we have a lot of special things, the nuts, the screws, the connectors, they are not made of metal anymore. So we have been evolving the system to make it different in 4 key variables. Those are the quality, the safety, the adaptability, and the efficiency in cost. So let me quickly address each of those. First, if we talk about quality, for example, the floats, the main floats, to the best of our knowledge, we are the only one that are producing the main float with injection molding. And why it's good injection molding? Because it's the most precise way of manufacturing. That's why it's used in the automotive, in the aerospace industry, and you can put the raw material exactly where you want it. In the previous other type of manufacturing that we use, it was an approximation. It was the same batch of floats would get 2 floats, cut them in the same corner, and the thickness of the 2 floats would be different. You don't want to create a floating solar structure that the components, you already have one weak float connecting to other stronger floats. And the fact that we use injection molding, it has let us put the raw material exactly where we want. I told you that we have 3 millimeters, the minimum thickness, and 3 millimeters is at the bottom of the float where there is no UV radiance and no mechanical stress. It's just floating. But in other parts, with the analysis that we have been doing, you can put, we have put 4, 6, even 8 millimeters of thickness, exactly where is more needed. We have also put in and using the best material. We use HDPE virgin. Why? Because it's the one that preserves more the properties that the producer of the HDPE is stating in the data sheet. It's also very good from a manufacturing perspective because we can produce very quickly 1 megawatt of float in less than 5 days, and we can scale the manufacturing using machines available from injection molding companies. And we do a lot of testing, the traditional testing, but look at this type of testing that we have done with one of the most renowned institutes in marine environments. This is the type of testing where we are stressing the system. This is high waves and with a high frequency. And sometimes the frequency is the most challenging from a structural point of view, not necessarily the big wave. And you can see how the system, what it's doing is surfing the wave. It's not, what we have tried to do is that there is not a significant resistance from the structure, but it's more how to adapt to the conditions. If you fight nature, nature is gonna break you. That's why we reduce the tilt on the panel, because supporting high, strong winds for 25 years is very difficult. So it's important to go for low tilt and to have elements that will be flexible and will be able to adapt to the conditions of the reservoir. On safety, the two main things for us in safety is safe for the people doing the O&M, so that there is stability and buoyancy. And you can see people, in our structure, there are no holes by a person could fall into the water. The floats are not flat at the bottom. They have design similar to a catamaran to provide greater stability so that it's good for the people, and not just when they're walking. Imagine they need to change a PV panel. It's going to be 2 workers carrying a PV panel, or a string inverters. With a string inverter, probably the unit that is walking is going to be weigh more than 200 kilos. And is that going to be enough? Yeah. Will there be any problems of people touching the water? There are many pictures of floating solar installations and that they are walking and they are already touching the water. And imagine with a PV panel or an inverter. And also the safety, as was mentioned, on the wind load. Wind load is critical and you need to pay a lot of attention to that. And finally, adaptability. Adaptability to the changing conditions. Water is always changing. It's not like ground mounted that stays unless you have an earthquake. But here, it's always moving. So here you can see an example of our technology that it's on top of an artificial irrigation pond, that usually these ponds might get completely empty. And the connectors, they can bend up to 70 degrees without breaking, and they can be resting on the slopes or at the bottom, because again, the thickness, the minimum thickness is higher, it's 3 millimeters. So it's not going to break just by touching the bottom. There are something that cannot be done while if the reservoir is empty, like walking or doing, but the system can adapt to some of these extreme situations. It's not designed to work as a ground-mounted system, but more and more, weather is becoming extreme, and you need to be able to have a system that will be able to withstand those extreme conditions from time to time. And another thing that is relevant is how compact the system is, because usually you don't have a lot of space. You want to reduce the environmental impact. So the smaller you can do the whole structure, the better. And in the adaptability, it has been mentioned by Shiv and Hans that water level variation, this is critical. So we decided to have a partnership with a Swedish company called Siflex that produces elastic mooring components. And why is this relevant? You can see here a simulation on the left of traditional chain and ropes, and on the right, the Siflex system. And you can see how significant is the variation in the horizontal and the vertical movement. And every time that this gets to the maximum level of elongation of the ropes, it creates a pulling, a peak force into the structure. And those peak forces can be significantly higher. There is movement on the right, of course, but you can see that it's less strong and it's less sudden. There is less pulling. When you put that into an analysis and in a graph, this is what happens, that with the traditional anchoring and mooring, you have these peak loads that are 2 or 3 times higher than the load that you're getting with the other system. This peak loads reduces by 70% the longevity and the problems in the structure. So what's going to break first? Again, a chain made of metal or a structure made of HDPE or other components. So it's important to keep all of these things in mind, because it's the combination of the structure, the anchor and the mooring, and how to adapt to the challenging conditions and changing conditions so that the structure will last. And finally, on the cost efficiency, again, this is very relevant. Many of our clients, when they start asking us, they ask about the cost of the float. And we tell them, look at the total cost of ownership, the TCO of the structure, because you don't only pay for the float, you pay for the logistic and for the installation. And even if the supplier is giving you a total price for everything, they are paying for the logistics. And this can be very relevant. And here you have a picture of our technology. In one column, you can put 43 containers, 43 floats. In the other system, you can put 10, 11, 12, 13. So that means that you are paying 3 to 4 times more money in containers. We were doing a design for a 50 megawatt project in India. The total cost of the logistic, it was in a remote place in India in a hydroelectric facility, was 11 euro cents per watt peak, just the logistics. And 65% of that cost was the local transportation from the Mumbai airport to the site. And it was in a mountain area, so you couldn't bring a big container. You needed to move things to smaller trailers. This can be a big difference. And imagine, that means that if the total cost with other technologies is 11 euro cents, with our technology, it's going to be 3 to 4 times less. 3 euro cents, 4 euro cents. So look at that, and also take a look at the cost of the logistics, because the cost of the installation, because that will also be a relevant thing, and it can maybe be around 1 euro cent of difference. So the efficiency in cost is relevant, because at the end, everything adds up: the cost of the float, the cost of the logistic, and the installation. And the same, it's on demand maintenance. Look, remember, in floating, you don't have the ground and you don't have the roof. In the other technologies, that is cheap, that's free. It already exists. In floating, it doesn't exist. So you have to spend money to create the ground by where people will walk. So what we decided to do was to put a system of highways and streets. So the highways are the float, the secondary float. Those floats are expensive and you need them to walk. Okay, we need to build some highways. But let's suppose that a person needs to do something here in the middle of this plant. What they will do is they will walk through the highway, they will get here, and then we'll go up through the streets. And the streets are the space that is available when you connect 2 floats, so that there is enough space so that the feet of a worker can fit there. They walk like they would walk in a rooftop installation that have reduced space. And here you have an example of how they walk in a real-life installation where there is enough stability and buoyancy for the worker to do that. And you are not spending money in a lot of maintenance walkway. You put that money in the structure, in the main float that are the ones that need to resist all the challenges and support the PV panels. Or you put that money where you need to do the evacuation of the cables or the string inverters. So this is relevant. And if you are thinking of big plants, we also recommend that you look at options of robotic cleaning. Robotic cleaning, we have companies that have already certified their technology to work with our system. And here you can see how this type of technology works. Very little manual assistant. These are heavy robots that can weigh 100 kilos. Does the structure have enough buoyancy? In our case, it does. You see, it's moving independently from one float to the other, even on top of the maintenance walkway, and it doesn't sink. The float don't sink. Some of these robots can even turn in itself and move from one row to the next row and then come back. They need the assistance of a person to change batteries, to change the hose, but this is also a potentially good solution for the fact of not having and not putting a lot of maintenance walkway and increasing the cost of the system in parts that are not the most relevant parts. And here you have, I'm gonna just give you a glimpse of some projects, yeah, and the oldest project in Spain, 11 years. These are projects done to reduce water evaporation, where we are covering almost all the surface. Even when water level goes down, floats will be resting on the slopes of this reservoir, or other plants that are needed more for irrigation purposes that you want to optimize the total cost of the energy, or this plant in Chile that this gets empty every year. Every year during the summer, this plant gets completely empty. It's almost 10 meters of depth, and the water is more crucial for the client, and they need a system that will be able to withstand those conditions. And here in dams, how do you cope with significant water level variation? Here, this dam, it's about 28 meters water level variation, and how do you design correctly so that the system will last the 25 years of expected lifetime? Well, thank you very much for your time. Now let's open for questions on the presentation. Please go ahead.
Thank you, Mr. Andra Franco. Questions, I mean, kindly unmute yourself and pose the question.
Do you have any experience of laying this floating system in a dam, say hydropower, or maybe a big river dam, worked for a big reservoir connected with a big river and a reservoir with a high depth of, may say, 80 meter to 100 meter?
No, we haven't built a system yet with those conditions. The most complex one that we have built, design, is a 96 meters of depth, 43 meters water variation in Latin America, where there is the mountains are very steep, and you get winds of around 160 kilometers per hour because there are canyon winds. And the river, there is a river that feeds the reservoir. In that case, you need to adapt the design. We had to put a windbreaker, a wave breaker, and a protection, because when the river grows, it brings trees and rocks that can hit the structure. And the floats by itself, they will not last. So you need to put a pontoon around that acts as a protection for this whole system and reduce the potential damage.
But what about the, say, with the high variation, high depth, and the underwater currents, the, say, anchoring and mooring system complexity? One is the design, and another is the cost part.
Yeah, it's true. And I think this is a very good point. Just because you see a piece of water, don't think that that water is good for a floating.
You are mute, sir. Andres, sir, you are mute.
Okay, sorry, somebody mute me. No, I was saying that what you have said is completely right. And this is a challenging situation. And what you need to look is, at the beginning, choose wisely the site. The cost of the anchoring went up to almost 9 euro cents per watt peak in order to cope with those challenging conditions. So not every piece of water is good for a floating solar project. Many people believe, oh, water, we can do anything there. No. We have several cases of clients that bring us ideas, and we said, we don't advise to install here unless you're willing to pay what it costs. If you pay peanuts, you get monkeys. So be careful on your site location and identification. Cost can be very high, but it's what is needed to last. You don't want to be in the news like all those pictures that you saw. Remember, I told you, all those pictures, the oldest one was 4 years. Only 4 years, and you are making investment for 20, 25 years. More questions, please. Now I think it's Credel who is mute. I think Mr. Credel Ik, you are mute. We cannot hear you. I see you moving your voice. Okay, so another question.
Hi, Andres. It's Kushagra from Tata. So you, for the longevity part of the floating plant, you had given one example of Eisner. So that is, I think, the oldest plant, right? Which has been more than operating for more than 12 years. So have you used a 3 mm HDP in this? Because fatigue, from what I heard, is one of the most important aspects. If I see.
Yes, when we started, we didn't have the 3 millimeters. We started with 1.5. We thought that 1.5 was going to work, but then we realized that it was not going to be enough. And from the real life experience, we have decided to increase the thickness. And we know that that's an extra cost. But what we want to do is to have the structure that will last, not the cheapest one. If your project is for 10, 15 years, there are very good and economic solutions available. But when you're thinking about more than 15, we realized that it was not enough.
Okay, but the 3 mm 25 years is doable, right?
Yes, it's doable if you take into account other things like the flexible system to reduce. If you reduce the tilt so that the wind load will not be enough, and sometimes you might need to put, as I said, protective measures to reduce the waves from hitting the structure, and also the wind for hitting the panels. So you need to look at everything. It's not just one parameter. This is one of the most complex things in floating. Even if you do one test, we have said, oh, I have this test on the wind tunnel test. Yeah, but it's one factor, and it's the combination of the wind, the wave, the water level movement, the structure, the anchoring. That's what you need to solve. And as time passes by, you learn what works and what doesn't work.
Sure. Thank you, Andre.
Okay, more questions? Mr. Credel, you are mute. You are mute. You need to unmute yourself.
Yeah, as I was asking is there any like module and components? We have a lot of international accredited body that who can certify this design, everything. Do we have in this floating system that say the material of the floating itself, the design life certification? I'm talking about the certifications. With the independent body, the floating system, similarly the certification, third-party certification agency for anchoring mooring system, say complex anchoring mooring system. Is it available worldwide, or who are they? Consultants and all are available. I am talking about the institute.
Yes, yes. Well, thank you for the question. To the best of our knowledge, there is nobody that is producing that certification. We have talked with TUV, we have talked with Black & Veatch, with the DNV-GL, to see if they had a certification and we could certify our system. There's no standard yet. Series is working on creating a standard. And one of the things that we're doing two things. There are no standards. We decided to, I wanted to share, but okay, now I cannot. It's okay. We are working with DNV-GL in a worldwide effort to create a joint industry program to write recommended practices in floating solar. But it's not going to be a certificate. And the second thing that we are doing is working with Black & Veatch to provide so that they do an independent assessment on the bankability of the technology. But it's not going to be an international accredited certificate. We don't know of anyone doing that. If you happen to know it, please refer them to us, because we'd love to talk to them.
It's a good effort you are making. It's a good effort you are making. But in this industry, if we have to push this industry forward, we have to evolve such things. Maybe DNV-GL and you and some more guys collectively come together and make a common standard, a common platform. as a utility part, we where to go and how to get certified, and particularly as a institute, government institute, we face a lot of issues. Then we apply our common sense and say renowned personality and all, and then get together and take a decision ultimately. But it's a good effort by you that you are moving such things.
Yeah, one last question from Credil. I think Credil, you have to unmute yourself. You wanted to ask a question. Credil, you have to unmute. I think the gentleman is not able to.
No.
Sorry,
Mr.
we are
Credil.
not able to hear. No, Credil.
Yeah, if you cannot unmute, you're gonna. Now go ahead. I see that you can talk now.
Sir, can you just share the breakup of the last project you have done?
Excuse me?
Breakup of the last project, your recent project.
Okay. No, we finished a couple of weeks ago a 1.2 megawatt project in Irrigation Pond.
No, breakup.
Okay, what is
recent
breakup?
Project, cost of the project.
Oh, we don't build the project. We don't build the project. We are not the EPC. We supply the EPC or developers our technology. We do the design, the manufacturing, and the support on the installation. But the EPC is the one that puts and builds everything. So unfortunately, we don't have access to those numbers. But I agree with what was said before, that floating solar is more expensive, and I believe it will remain more expensive. You don't do floating solar because you want to do it cheaply. If you want to do floating solar cheaply, you're going to fail. You do that when there are no good options in ground mounted. My recommendation is, if you have a good connection to the grid and you have the land, do ground mounted first. Only when you don't have the land or you care about reducing water evaporation and you're willing to pay the premium of the cost, go with floating solar. Floating solar will be a segment of the market, and it's not going to be the cheapest segment of the market. And I don't believe it's going to be the same price, because you need in the structure, as I said, you need the structure to support the PV panels, same as in ground mounted rooftop, but you are paying for the ground. You need to put something on top of the water. If not, people sink and components will sink. So you are providing two functions, structure and also creating the ground. So that costs more money, and it will cost more money in the long term. Prices.
Thank you.
Andre? Hello? I think we have lost Mr. Andre Franco.
Hello, since Andre is not there, I am Sachin Relay. I am the promoter of Easy Floating Autonic. Happy to take the questions till the time Andre is coming on board.
Yeah, I think that was the last question from Credil. I mean, Mr. Sachin, we'll come back to you if there are more questions.
Certainly.
To email. Yeah. Thank you very much. Yeah. It was a wonderful presentation from Mr. Andre Franco. Yeah. Thank you very much.
It comes from his heart. He's very passionate about floating.
I know. I could see that. I could sense that. Yes, we could sense that.
Thank you.
Thank you very much. Thank you. Yeah.
Thank you.
So we go to the last but not the least presentation. This is on the solar solutions from Mr. P.S. Jamgaonkar from a company called CTR Manufacturing Industries Limited. Mr. Jamgaonkar is working as a divisional manager in CTR Manufacturing India Private Limited. He has over 25 years of work experience in entire gamut of renewable energy and cogeneration plants. Mr. Jamgaonkar, the floor is yours.
Yeah, so good evening. Am I audible?
Yes, sir.
Hello?
Yes, sir.
Yeah, you are audible. Yeah, you are audible. Yes.
Thank you for the nice introduction. So we begin with the presentation on solar solutions with focus on data management from CTR. So first we start with about CTR, the organization, then a talk a bit on the floating solar and the solutions that we offer from CTR. Just to brief, CTR is an organization which is established in 1964, catering to electrical components, especially into the substation part of it. We have our manufacturing facilities in Pune, in Aurangabad, and in Nashik in Maharashtra, India. The headquarters are in Pune. Presently, the manpower is upwards of 725 people, and the annual sales turnover is 50 million USD plus. Just to add on, it's an ISO 9001-2008 certified company, and we are having a wide gamut of products. So the initial product lines were capacitors, the tap changers, and the radiators, and that is how the name CTR was derived from. Slowly we have expanded and gained a foothold and market leadership in various other components like the transformer explosion prevention systems, also popularly known as the NIFPS, the protection devices, relay panels, substation automation, C&R panels. Then we have also worked out solutions for increasing the transformer life. Then we have also worked out some solutions for passive fire protection system. We have our own diagnostic products, the material handling equipments, the railway track maintenance equipments, and we are now extending some of these products which are relevant to the solar industry. Now just the floating solar part, it's like another solar project, but the key challenge, as all the veteran speakers have pointed out, is with the solar mounting on the water, and those are the challenges with certain benefits which have been widely spoken about. So I just give it a miss. Okay, and we'll just move on to the solutions that we offer as CTR. So this is a typical layout for a solar plant, whether it is you have the modules, then you have the combiner boxes followed by the inverters, the AC conversion to the panels, the step-up transformer, then the HT switch gear, and then the transmission line. And then we have a data monitoring system for this. So CTR fits in and has solutions for all the aspects of the entire solar plant and even the grid side of it. So the material handling solutions we have, in the material handling solutions, we have our stacking equipments, we have material handling equipments. For the power quality solutions, we have various equipments. We also carry out the energy audit solutions. We also have the STATCOMs, the SVCS, and some of the other components, other products have been covered into the presentation in the next few slides. In the protection solutions, we have the arc and flash prevention system. We have the nitrogen inducted fire protection system, or popularly called as an IFPS. In the monitoring and communication system, we have solid insulation mixture. We have C&R panels, and we have various other solutions which we will cover in further details. Now let us look at the PV system monitoring schematic. So in the PV plant, we have the monitoring required for the inverter, for the meters, for the power transformer, the grid side of it, and these are monitored through the SCADA. We have fetching the real-time data. We also get to see the historical data, and we also get the alarms via SMS or email, and nowadays even on WhatsApp for the various activities or the alarms, those are getting raised. The meteorological station data like the wind speed, the temperature, the solar irradiance level, these are also sensed and these are also communicated. So we have designed this system which are communicating with the main monitoring center via the digital subscriber line or the GPRS or through GSM based on the site situation. These are then through web interface. We have the reporting and various monitoring and visualization system. Nowadays with this forecasting and scheduling coming up, those parameters are also incorporated into our system to generate the suitable reports. So the various solutions, we have our existing products for the protection devices. We have in the real RPFC panels, we have the HFR or the shunt and series harmonic filter reactors, the SVC that is static voltage, synchronous compensator, and substation solutions. Apart from this, we have also entered into the O&M, operation and maintenance services for the rooftop and ground mounted solar projects, and we are also entering into the power and energy storage solutions. So now looking at the protection devices, this is a typical layout for a transformer and NIFPS. This is one of the most popular product in the industry and is being catered to through all the IPPs and the developers in the solar industry. So I'll just keep this and just some photographs of this. So this NIFPS, we have installed over 15,500 MVA transformer. More than 12,500 systems are supplied across 5 continents. These systems are operational from as low as 750 kVA to 1500 MVA range and 765 kilovolt class product. All the NIFPS comply with the NFPA, CBIP and CEA specifications. These are meeting all the present specification and standards, and they all work on the DC voltage. These NIFPS products are SCADA compatible, and they are SCADA compatible in all the communication protocols and in operation. So we have various models to protect the online tap changers, the cable box, the filter units, and all these are in-house designed, developed and manufactured here in India itself. We have a very strong team of service engineers who would cater to 24/7 for any of the issues those come up. Apart from the NIFPS, we have other protection devices like the fire doors, the bandages, the fire paints and the fire barriers. All these products are complying with the national fire safety regulations and national building codes. The next product we talk about is the real-time power factor corrector or the RPFC. So this product is suitable for loads like commercial building, offices, educational institute, large residential buildings, solar plants, and they are used to optimize the PF and the reactive power. Just to an information of how it works. So just one sec, I have a call and I need to attend it.
Hello, this is Andres Franco. I'm back. I had problems and got disconnected. Please later, if you have any other question that I couldn't address, send an email or through the organizers of the meeting. Thank you very much, everyone, for your time today.
Thank you, Andres. We will do that. We will definitely come back to you with more questions. Yes.
My apologies for it's not an important call and I needed to attend it. So coming back to, am I audible, gentlemen? Hello?
Yes, you are audible. Yeah, go ahead. Yeah.
So coming to how this panel typically works. So they continuously monitor and correct the power factor real time by injecting the required reactive power through all the 3 phases so as to maintain the PF above 0.999. These are highly customized solutions with and the client has a wide range of capacity. Sir, one sec, sorry. So I'm back, guys. Sorry for the trouble. I hope I would be now available continuously. So we have a wide range of capacities available, the heavy duty, the super heavy duty, oil impregnated, the anti-resonance reactors, and with a high linearity and wide range of voltage drop up to 14%. With appropriate switching devices and advanced control monitoring and protection features, apart from data logging and communication facilities, including the RS-232 and RS-485 communication port. These are available from single unit 10 kVR to 1000 kVR and 1 to 16 stages. Next, we would talk about the shunt and series harmonic filter. A shunt and series harmonic filter is a typical product which is required to block the high frequencies to avoid the magnification of the harmonics. So we have the shunt reactors which are designed to achieve the tuning of the required frequency, and the series reactors which are designed to block the high frequency when connected in series. So series and shunt combination, they form a unique frequency tuning which is implemented for equipment high level harmonic mitigation. This product is designed to have a low noise and low losses, very high linearity and a very long life. The NC contact is provided for excess temperature rise. The standard range that we are offering is in low voltage with a tuning of 2 to 14%, and in medium voltage that is above 6.6 kV. These are with tuning from 6 to 12%. A high level of safety is provided through internal fuse and optional over temperature sensors, which include compact discharge resistors, which are aluminum or copper wound as per the application. The MV and HV range are available in single phase and tower configuration. So in MV range, we go up to 22 kV of application. Then we refer to the SVSCs, synchronous compensator. So static voltage synchronous compensator or SVSC, they are, apart from voltage stabilization in various loads, they are also used for stability improving of the PF. They sense, the monitor and control the voltage and current waveform by injecting the reactive power dynamically. Connected in shunt with load and source. So whenever the reactive power demand increases, the STATCOM increases the output voltage and allows the reactive power to flow into the power source. Similarly, if the voltage has to go down, if the voltage set values, then the voltage is reduced by and the reactive power is absorbed to stabilize the voltage between the predefined set values. The VSCs are the heart of any STATCOM which uses DC capacitors to provide input voltage and a small amount of active power. Also, they absorb the reactive power which helps to stabilize the voltage and operate with ultra fast response time to compensate for low voltage dips, flickers, and control the PF also, thereby reducing the need for separate harmonic filters. The STATCOM is able to inject capacitive as well as the inductive reactive power, and this is dynamically fed through fully controllable power electronic devices. Then we come to the substation solutions. In the substation solutions, so we have the digital data and protection system for substation, which uses the intelligent electronic devices or the IED's controlled and automation system within the substation and control commands from remote users to control power system devices. These are complying with the IEC 61850 edition 1 and edition 2, the substation equipment accessories for improving performance and decreasing the downtime. The substation automation system, these are substation automation system based on the advanced client server architecture, which are compatible for various network topologies and communication protocols, including the IEC 61850. We are the registered partner of COPA Data Partner Community, Xenon platform chosen for developing CTR CD Xenon software. These are very high reliable in exchange of data and storage of the data. They permit the hardware and software expansion of the system. We have an open source, object-oriented, hierarchical, decentralized architecture which is suitable for all basic SCADA levels, fully compatible main and redundant switching between the servers, which are compatible with all the versions of Microsoft Windows. Configuration can be done locally as well as remotely. These are local and remote diagnostic tools available, wherein the connectivity is available with the web server. Then we have the C&R panels or control and relay panels. These C&R panels, they are designed as per the utility specifications or the end customer requirements. They are available in simplex and duplex type customized panels. The protection schemes are designed for medium voltages from 11 kV to extra high voltages up to 400 kV as per the specifications. The testing and commissioning works are carried out by experienced testing engineers using the calibrated testing kits. These are designed to have a precision logic diagrams to understand the overall scheme at the first glance. They have protection schemes. Those can be designed for various bus configuration and then dedicated DC supply for each protection and each circuit. The trip system supervision from each and every initiation contact can be monitored remotely as well. The wiring perils are as per the BEPS 12 standards. Now coming to the new offerings. So in the solar space, we have recently begun with our operation and maintenance services. So O&M services we are carrying out for the rooftop project, for the ground mount solar projects. These are both comprehensive as well as non-comprehensive type, wherein we take the solar O&M for within the array as well as for the transmission line. Herein we assure the high plant uptime, and in line with the present designs, the PR is guaranteed. We have a team of skilled and experienced people who carry out the O&M for both rooftop as well as ground mounted. Just to add on, we also have our own rooftop, our own solar projects, which are just maintained by us, and in the last year or so that we are maintaining these, the yield has gone up significantly. Our team is very skilled and capable of monitoring and taking the corrective actions immediately with a back-to-back tie-up with the vendors, with the major component vendors. Next we come to is the power, energy storage and the converters. So herein we are referring to the energy storage. So as we all know, typically the batteries are used for energy storage, and lithium ion is the most promising one that is there in the industry. Most of the projects you would find are opting for the lithium ion. We have come up with something different which we believe is much better from economical point of view, from the ecological point of view, and even from the LCOE point of view. These are the redox flow batteries or RFBs, wherein at least one electrode comprises a solution of an electroactive material, and the energy is generated or stored when the redox species flow through the electrochemical cell, anode and cathode chambers, as depicted here. One of the RFB electroactive material may be flowing liquid or a gas. A number of electrochemical cells are connected in series or parallel, thus they form a cell stack. Electrolytes are stored in separate tanks and flow into the similar to fuel cells, because in both the cases fuel and oxidant are stored externally and supplied to electrochemical cells. The RFBs are regenerative fuel cells except the discharge redundant. The most common solvent here is water. Although we can have a number of non-aqueous solvents in this. The RFBs there are certain limitations also to RFBs, including the redox potential, the electrochemical reactivity, etc. Right now, because of the low energy density, these are not suitable for mobile or electric vehicle application. Although they are instead some distinct advantages, that they are not location specific, they are highly modular in nature, and the power and energy is a separate function and hence scalable on each parameter independently, with the ability to hold the charge for a long duration and ability to discharge 100%, unlike in case of lithium-ion batteries. There is no loss.
Mr. Jamgaonkar, you will have to rush. I mean, we are already behind schedule.
So, my apologies, I just rushed to the same.
Yeah.
So just to compare, so redox batteries or the RFBs, they are in terms of cost, they are higher by 25% initially, but they are much safer. The lifespan is much longer and designed for 25 years of operation, 20,000 cycles. The 100% DOD is okay with this kind of application. They are unlike lithium ion, they have both power and energy applications, and only disadvantage is the power energy density is lesser, so occupy more space, although the life cycle cost is almost 50% to as low as 33% of the lithium ion. This is the last slide on the converters. So we have battery to grid converter, which are very high efficiency modular kind of converters. So these are full power converters for battery storage system with liquid cooled IGBT power stacks and ultra fast control systems in the power range of 250 kilowatt to 6 megawatt. That is quite a wide range, I believe. The advanced customized features and the grid support system, that is the enhanced frequency response and primary operative reserve, as well as reactive power compensation for high dynamic grid voltage control, are suitable for storage plants of up to 100 megawatt, even more. Then we come to the multi-source converters. These are the hybrid converters, power converters, which are based on multi-source concept. The multiple energy sources, for example, the solar or the wind, etc., can be connected on the DC link of the power converters. This does reduce the installation cost and achieve a higher level of system integration as well as grid stabilization. These are available up to 3 megawatt of range. So I thank you for a patient hearing and sorry for overrunning of the time, sir.
Thank you, Mr.
Since we are short of
Jamgaonkar.
time, I would request any queries you have, would request to send it via email on the email IDs mentioned here, and we would surely address.
Yeah. Thank you, Mr. Jamgaonkar.
Thank you so much.
I'll
mute myself.
Thank you very much, ladies and gentlemen. We had a very wonderful session, quite comprehensive. Whatever questions you have for today's speakers, you could just send it to CBIP, the organizers, or to IGEF, the co-organizers, and we'll be happy to get responses to your questions. With that, we come to the end of today's session. We will start 2:30 sharp for tomorrow afternoon. Please join us for the next three presentations tomorrow. Thank you very much and have a nice day. Thank you.